folks. Let's take a look at the schedule first before we get started. Okay, so today is the 20th of November. We're going to be going over chapters 27, 28, 29. We're going to be looking at security in Unix, monitoring, and performance analysis. And really, it's kind of funny that monitoring and performance analysis, it's really the same. I think as the author got down, I've noticed in these technical books or class books that we utilize a lot of times that you'll find these chapters where the author was just kind of pushing a little bit like, okay, let me split monitoring into performance analysis. Well, performance analysis is part of monitoring. You monitor something so that you can get performance statistics out of it, okay, and understand what's going wrong, more capacity planning. So we'll be taking a look at that. You'll notice that we've got UNIX Lab 12 and 13. So I will be going over those two UNIX labs to do. And, the really 13 and 14 are pretty easy labs as far as, but I'll go over that here in just a couple minutes. Or, well, not a couple minutes, after the lecture. Where should you be at in class? Well, today's 20th of November. You should be done with up to chapter 26 quiz. Once again, if you're not up to chapter 26 quiz, you're behind in class. You should also be done with basically Unix 11. Unix 11 was that Fedora core and MySQL that we went over last Saturday. And that CATS database. Okay, so you should be done with labs 1 through 11, chapter quizzes 1 through 26, and by next week, well, okay, so you'll notice here that next Saturday is Thanksgiving off, okay? So there is no class next Saturday. But you have 2 weeks, folks, between this Saturday and our next class. By our next class, 2 weeks from now, you should be done and up to chapter 29 quiz, and you should be done with UNIX Lab 12 and 13. Okay? Any questions on the schedule or where you should be at? Answer no in the chat session or feel free to ask a question. Okay. Now, on this last Saturday, this is really a lab catch-up. I am going to go over lab 14 and 15 on December 4th when we come back. But this last Saturday here is really just a lab catch-up. If you finished all of your work on this Saturday, I'm not going to be taking roll. It's just there in case somebody needs some lab help. If you dial in and work on your labs or you have lab questions, well, you can dial in on this last day. But you don't, or if you just want to say, see you later, Professor Wade, you don't necessarily have to, but this last day, what I'm going to be doing is the online participation grade. I'm going to look and see, well, how many classes did you attend? I'm going to take those snippets that you normally see. And, I'm going to give you your attendance grade. Now, how do I do that? Well, let's say you made all the classes and your name is on every single one. Well, you get 10 points. Let's say, though, that you missed 40% of the classes. 40% of the classes, you would get 6 points. However, if on this last day I log in and you're finished with everything, if I'm doing that participation grade and I go submit that into Blackboard is what I do. If you are finished with your final exam, you're finished with all your quizzes and labs, and you're, for all intents and purposes, done with the class, I'll up it by 2 points. Okay. So, you get a couple points. You still take a hit for missing the classes, but not as big a hit. On the other hand, if you have attended all the classes and you know, you're a little behind, you're maybe back here or here trying to catch up, then you know, you still get the 10 points because you were here. Okay. Any question on online participation? Answer no, or feel free to ask a question. Okay, well, let's begin our lecture, folks. And once again, you know, you got 2 weeks between this class and the next class. You want to keep up, you know, continue to keep up. If you're behind, you want to push and get that work in, because, you know, we've really only got, you know, one more Saturday, or excuse me, 2 more Saturdays. That's it. So basically, 2 weeks, 2 weeks of class. Okay. Now, granted, this week we're off. Okay. Next Saturday we're off. So really got 3 weeks to get all your work submitted. But yeah, it's coming down. We're down to the wind down of this class and this semester. Okay. Christmas is coming up soon, right after Thanksgiving. Okay. So let's talk a little bit about security. Okay. Don't skip it. Okay. Notice it says, the author says, hey, if you're tempted to skip this chapter, well, let's remind you of a few computer security events. The sophisticated Stuxnet worm, discovered in 2010, attacked Iran's nuclear program by damaging centrifuge at their uranium enrichment plant. In 2013, Edward Snowden exposed massive NSA surveillance machine, revealing major internet companies were complicit in allowing the government to spy on U.S. citizens. Around 2013, a new type of attack known as ransomware came to prominence. Attackers compromised a target system and encrypted its data. 2015, U.S. Office of Personnel Management was breached, compromising sensitive and private details of more than 21 million U.S. citizens. In 2000, oh, look at this, many who had security clearances. 2016, Russian state-sponsored hackers mounted a campaign to influence the outcome of the presidential election, allegedly. Okay. In 2017, ransomware attack of unprecedented scale took over Windows systems in more than 150 countries. And the attack used an exploit developed by the NSA. Okay. So we all have heard of stories like this, where people have hacked in, or gained sometime, and sometimes it's not from outside, it's from inside. You know, it's, you know, they say about 59%, you know, of, you know, leaks or hacks are from inside employees. Okay. That work for that company, taking the data, stealing it. And, you know, that makes sense to me, because if you figure large scale corporations, well, they have employees, you know, thousands of employees at times. How do you keep track of all of those employees? So, now, what do you think? Do you think that, do you think that, what do you think, Windows or Linux gets hacked in the most? What do you think? Windows or Linux? Yeah, Windows. Windows has everything but the kitchen sink. Okay. Everything but the kitchen sink. And what do I mean? Well, let's go take a look at my system here. I'm going to pull up the task manager and look at this. This is crazy. I mean, I only have a PowerPoint presentation and the WebEx session and my video camera, you know, probably a handful, maybe 10. And look, is this not crazy? I'm still scrolling down, 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 down. This is crazy. I mean, look at all of these little, you know, programs running in the background. I don't know how many of them have open ports, you know, to this system, but it's just crazy. You know, every time you load something onto a Microsoft system, um, Yeah, you know, James, they say Windows 11 has the best security. Yeah, I don't believe it. Okay. Although my understanding is, and I haven't really dug into Windows 11, my understanding is that they're starting to put Unix on the back end. Okay. Uh, yeah, that's true, Seth. Linux without an antivirus is more secure than Windows 10 with almost, 2 tons of antivirus and malware. Let me ask you a question. Why do you think that Linux is a little more secure? And by the way, that we're not saying that I'm not saying that Unix does not have security vulnerabilities. It does. Okay. Why do you think that Linux compared to Windows has, Windows is Linux is a little more secure? Why do you think? Yeah, that's it right there, Easton. More services, more attack vectors. The problem with Windows is, and this is the way their operating system works. You load a program onto Windows, and it loads a dynamic link library as part of the OS. So I load a program, and all of a sudden, it becomes part of the OS. It loads a library into the operating system. You go look in the registry. The registry will have that, little dynamic link library, a library that a program needs in the operating system. And every time you load a program, so literally you can load some software with Windows and it breaks your system or something weird starts happening to your system. The Some of the labs that I've been doing in other classes have been a pain because about 80% of my labs work just fine. And I'm not talking about ours because ours is mostly with VMware, but even VMware on Windows, or not Windows, on Mac, on the Mac OS, has a little bit of problem because the operating system of Mac, they kind of changed it. So Big Sur has some problems working with VMware, but the biggest problem's been on the Windows side. So about 80% of the software seems to work just fine, but about, say about 80 to 85%, but about 10 to 15% folks have problems. Okay. And it's always with Windows boxes all the time. Windows boxes. Um, yeah, and then there you go, James. So James says he's installed Windows 11. Some of them don't work. That's because the dynamic link libraries, were probably written and sourced with Windows 10. But it is just crazy. Now, so compare Windows to Linux. With Unix, yes, you have the operating system, but with Unix, when you load a program, it doesn't load a dynamic link library. That program doesn't become part of the operating system. The operating system is separate. The only time that, let's say, a program could interfere with the OS is when you bring it up. So we load a program, all the files go self-contained into a directory, and they're in that directory. And then when you bring up the program, it's loading it from that directory. It's not becoming part of the OS. Okay. Now, can it still cause problems, a program? Well, sure. It could still have a Trojan from security standpoint, or, where'd you get it? Did you get it off the web somewhere? Great program for Linux. Use this. Or is it open source? It is more secure because, well, we administrators, we make it so. Okay. We make it so. How do we make it so? Well, we don't load everything in the kitchen sink like Microsoft does. We don't have 2 tons of service. And we certainly don't want a GUI. GUI are for Linux desktop folks. If people want to load Linux like Kali Linux or some other type of Linux on their desktop, great. Or if you got a Mac uses a Unix desktop in the background, okay? And then they have the GUI, but we don't use GUIs. Okay, so the Fedora core is a good one. When we did the lab on the Fedora core, we had a Microsoft SQL database. In the commercial world, that's exactly what we do. We load a database software on a Unix system, and you don't have a GUI. you SSH to it. Okay. So Unix cuts down all of that extracurricular activity that Windows has with it, and instead, just the program you need. Okay. Also, a lot of Unix servers, they will have a web browser. Remember, we loaded the web browser, and when we did the web, did you have a GUI with the web lab? No, because I've never seen a web GUI. And when I say a GUI, I mean a desktop environment. Never seen a desktop environment with a web server, on the Unix side. Now, IIS on the Microsoft, it runs all GUI. It's GUI, okay? Which is why a lot of web servers for commercial web-based applications utilize Unix, because it just needs that web server. Why do I want this Windows environment when all I need is a web browser? And if I really do need to do some type of administration, I can have an admin as part of that web-based browser. In other words, an admin section. Okay. So Unix is optimized for convenience and doesn't make security easy or natural. I'm going to disagree with the author. Some of the authors, I put this in there to show you with the author's opinion. I'm going to disagree with some of the author's opinion. And when I see this, it makes me wonder, well, how much Unix do you really have? Because Unix is optimized for convenience and doesn't make security easy or natural. Actually, Unix makes it's more secure because you have to load everything on it to get what you want. Whereas Windows, it immediately comes with the kitchen sink. Okay. The system's overall philosophy stresses easy manipulation of data in a networked multi-user environment. Okay. Once again, how long's the author been around? I've been around for 40 years. Okay. And Unix systems weren't networked. Okay. In the beginning, there's a bunch of them that weren't networked. You had to use tape drives, old style tape drives, to move and manipulate data. Mainframes are where networking started. They wanted to, instead of using tape drives to move data, old style reel-to-reel tape drives, they wanted to, exchange data over a network. So mainframes are where, network started. And it was easy manipulation of mainframes, okay, which had a Unix-based operating system. The software that runs on Unix is developed by a large community of programmers. No, that's not where it started, okay? It started with commercial vendors, and commercial vendors basically had their own programs that were specific to their operating system, and the chips behind, the computer chips or CPU chips were specific to the OS. So you couldn't take, say, Linux and load it onto AMD or, AMD or Intel chips back in those days. Unix only ran. It wasn't until Linux came out. When Linux came out, that's when it got more into a large community, open source communities is when Linux came out. Okay. But for years, it was just different flavors of Unix like HP UIX, Solaris, AIX, commercial companies that had their Unix, and they would sell it as a turnkey solution with their hardware. Okay, that's where it started. Okay. Range and experience level, attention to detail, and knowledge of the system and its interdependencies. As a result, even most of the well-intended new features can introduce large security holes. So yes, if it is open source software, potentially you have somebody working on it that may cause a security vulnerability. Okay. But that really didn't come out until Linux. And there are still companies today that they may use the Linux operating system, but they go to Red Hat because Red Hat is a commercial entity that will add their own code, add their own security functions, and they will support the customer, okay, to ensure that it is secure. And they communicate with open source communities like Fedora Core is Red Hat's kind of leading, I think it's funny sometimes because it's like Oh, it's like they're getting the open source developers to develop the software that they're going to use because Linux is open source. They can use the open source freely and then just add programs or functionality that they want to add to it. Most administrative functions are implemented outside the kernel where they can be inspected and tampered with. Hackers have broad access to the system. No, they don't. Hackers don't have broad access to the system. They still have to get in. Okay. They have to get into the system. Now, how do you get into a Unix system? There's only one way, SSH. Okay. Secure shell, it's encrypted. Now, how do I get into a Windows system? Through every single port that's open, which is a lot. Linux system will have some ports open, but they're the ports where you put a program that you wanted on there, like a web server or an app server or a database server. Those ports are open to connect to that application. But you can close down a lot more. By default, Unix closes a lot more ports than Windows does. Windows has tons of those layer 4 ports open, ready to go every time you boot up your system. Okay. So how is security compromised though? Social engineering, the human link, phishing, deceptive email, but also, regardless if that security hack is from the outside versus the inside, if it is from the inside, doesn't matter whether it's Windows or Linux or what the system is, if one of your employees has access and wants to steal the data or compromise it, then they're going to compromise it. Okay. There's nothing you can really do about it. As an employer, you can train employees. You can, basically do background checks on those employees to make sure that, there's nothing in their background that, might make them want to go out and steal data and give to somebody. But you're still at, as an employer or as an organization, a company, still at the mercy and the trust of your employees. Okay. What you can do, though, there are things that you can do in your company to, lessen the chance that they can get in. For example, you do a least ability approach. In other words, you make sure that whatever access you give to an individual is only the necessary access to do their job. That's it. Only the necessary access to do their job. You don't give them carte blanche. You don't say, okay, you have access to everything. No. Whatever you need access to do your job, that's what we'll give you access to. You also may not be able to prevent every hack, but you can minimize what's going to happen or minimize, the consequences of, let's say, a hack by making sure you have some type of security software that grabs all of the logging information, okay, and pulls all of that information into a centralized system so you can basically monitor what's going on in your infrastructure, on your systems. Software vulnerabilities, bugs, buffer overflows, configuration errors, software that's not patched, and, packages requiring updates. A lot of hacks have happened because of some old junky system sitting out there that they didn't take care of. Okay, here's a true story. Working for the state of Texas not too long ago, like about 3 years ago, I was working for the state of doing some work for one of the state organizations. I came on board and they were having some problems on one system. And so I started looking around and I checked their patch levels on the application server. They were using the AIX operating system and either WebLogic or WebSphere. I don't remember which one. I think WebSphere. Anyways, and I started looking. They hadn't patched the application server in 5 years, folks. They were using Java, an old version of Java 1.6 that had discontinued support. And so I sent an email and I said, well, I noticed that y'all are on an OS patch version that's 5 years. And by the way, they hadn't released this
the public. They had not released this to the public. They were still developing their application. 5 years later, they still haven't developed the application. I'm like, seriously, why is the state still hiring this company? It was a company that was doing all this. Like, why are they still hiring this company? And it's 5 years and you have no released application. That is crazy. You know, it was like they were just getting money from the state. And so I raised this concern. I said, you know, these things, you know, y'all are wanting to go live next year and you haven't patched these systems in 5 years, okay, including the operating system. And I said, you know, there's tons of security vulnerabilities in this. And you're using an old version of Java 1.6, which also has security vulnerabilities. And you've got some encryption algorithms that are utilized, you know, in your web servers that have security vulnerabilities. I'm like, when are you planning on patching this? You know, and the first response was, well, you know, we didn't want to break our application. Like, you're going to have to do it before you go live. Why didn't you have a patching policy? Like, patch every 3 months, and you wouldn't have had to worry that, okay, we're using old, you know, OS, Java version, all old stuff. You wouldn't have had to worry about this. Anyways, so what I ended up from that email was they started all these meetings on patching the software. I guess when I sent the email to some managers that I sent to, somebody woke up, but they started, you know, yeah, that's true, Lisa. They're so afraid of change. You know, the technology world works on change, folks. If you don't like change, if you're one of those that likes, you know, nothing changing, that you want everything exactly the same, and, you know, you're in the wrong industry because it changes constantly. I've been asked, you know, hey, go upgrade this software. And users like, no, wait. I got to get this. No. And I'm like, you know, and eventually they just forced it on the users. But, you know, yeah, you know, you've got to install these security patches. You know, you've got to install and the other thing they hadn't done is, because they hadn't, not just security patches on the application servers, there were also updates to fix bugs. You know, and you're like, you know, you haven't even stayed with the latest bug releases, you know, to get and not just bug releases, but also new functionality, improved performance, all of that. For 5 years, they had just, let's keep it where it's at. Okay. But another big thing on the Unix side is unnecessary services. If we do that netstat minus, you know, A, okay, well, then you get, here we go, on a Unix side, this is Solaris. It shows you these listener ports. And these listener ports, well, these are ports that are waiting for incoming communication. These are programs that have opened up a port listening for something. As a Unix professional, even as a Windows professional, we want to quiesce the system by shutting down as many unnecessary services that are not being used. On the Unix side, we do a really good job. Windows side, oh my gosh. I mean, you just saw it. I mean, look at this. I would have to look this up, every one of these up, like this: service host themes, service host remote desktop, service host radio management, service host phone service. I'm not even using a phone, okay? What the heck is that? Yeah, Windows has everything but the kitchen sink in here. And you start looking, okay, here's Microsoft Edge Web View. Okay, well, let's see. I don't even have any Microsoft Edge. It's not up. So why am I running some little process here? I don't want it. You know, I only want something shown here if I'm running it. And that's the way Unix works. Okay. Yes, you'll have some operating system, you know, items here, but Unix only works with, you know, what you have told it to run. That's, to me, its advantage. Other securities, users logging in, remote event logging. We can look at do syslog and grab that syslog information. Are we doing any backups? We have to look at backups from a perspective of, if somebody does hack in and change something, How do we get back to where we were at? Viruses and worms, less likely than Windows. They can still occur because somebody may say, well, I want to use this open source program, and somebody approves an open source program. You load that on, and it turns out it had a virus or a worm in it. A Trojan horse, with that virus or worm. Let's see. Easton says COA has Windows NT boxes still on the network around 5 years. Yeah, gotta love the government. Windows does not even allow you to manually turn it off. Takes 4 gigs. Yeah, I mean, when an operating system takes gigabytes to run, which is Windows, with Unix, you can have embedded devices with a tiny Unix kernel running in megabytes, okay, or kilobytes, even kilobytes. Tiny. With Windows, good luck. Rootkit, software that remains hidden, loaded on a system, giving root privileges to keys. Yeah, they have to have a backdoor of some time to deploy that rootkit onto your system. A rootkit is designed to do just that, give root access. Packet filtering configured, okay? One of the things that you have the ability to do, and actually it comes with Linux now, but back in the days, the Unix didn't have any type of firewall or filtering. We didn't use one, but they came out with a open source program, and you could take that. It was called TCP wrappers, and I used to deploy TCP wrappers on the system. And what it would do is you could lock it down to say, okay, I only want these servers to be able to access these ports. So you could, basically, if you wanted to, you could say, okay, if something's coming from my domain, you could even use domain, fully qualified domain names. You could say, okay, I want anything from this domain, okay, which means it's going to do a DNS lookup. Anything from this domain can have access, anything outside can't. So it was a firewall called TCP wrappers that we could install. Password complexity. Well, that doesn't matter if it's Unix or Windows. The more complex the password, well, the more secure it is. And do we have any security monitoring even set up? Once again, doesn't matter whether Windows or Unix, you have to have some type of security monitoring that's out there. And what are we monitoring with security monitoring? So you may hear security monitoring. What are we talking about? Well, you can have systems out there, intrusion detection, intrusion prevention systems that are monitoring the network, okay? You can have a network intrusion detection and prevention, or you can have a host-based, meaning you can actually have software. Yes, even on Unix, you can have intrusion detection software on the system. Now, you can deploy intrusion prevention as well onto a Unix server. What's it doing? Well, it's monitoring that network communication coming across the network card for that server. It's not monitoring the network. It's only monitoring the communication coming to that server and going from the server. And we can install detection and prevention. Problem with prevention is if you're not careful, and I've seen this, they want to install, security team says, we need to install intrusion prevention. And they install it on the server, and the next thing you know, all your apps are down. Because the intrusion prevention is seeing it as a normal software flow as an attack. So detection is a little more appropriate. It passively monitors and in alerts. But all of these security firewalls, access control list on routers, intrusion detection, intrusion prevention, all of that has logging information, performance information. And we can tap all of that into a monitoring tool that can monitor the security. Everything from the log files, we can aggregate that from all the servers. So if somebody logs into a system, we know who logged in. Wait a second. Jay Wade logged into this server over here. He's never logged into that server. That's an anomaly. Let's alert on that. Security philosophy. Don't put files on your system that are likely interested to be hackers or to nosy employees. When I see this, I'm like, does the author work in the IT industry? Okay. We put everything, it's all electronic now. You can't tell someone, now don't put anything in there that might be interesting to hackers, you know? It's like, okay, look at this, trade secrets, personnel files, payroll data, election results have to be handled carefully if they're online. That is very true. But you can't, you know, there's always going to be something interesting to hackers or nosy employees. Okay. What you have to do is figure out how to secure it as much as possible. You want to encrypt it. Okay. That'll give it a higher level of security. But still, you know, what you're doing there is you're encrypting it in case unauthorized users have access to it. But if they're authorized, you can encrypt all you want. They're still going to see it because they're authorized. Your site security policy should specify how sensitive data is going to be handled. Don't provide places for hackers to build nests in your environment. They often break into one system and use it as a base of operations. Yeah, some philosophy for companies are, we're going to put everything, all the protection, you know, the firewall, they can't get through that from the internet and us. Yeah, all the protection. Nobody can hack into our systems. Well, except the person that you hired. Okay. So really, when you look at security, it's kind of like and I don't think I have it here, but in some of the other security classes I teach, I have a nice little slide. It compares it to the old medieval castle. If you remember the medieval castle, you have, you know, basically the drawbridge that protects you from the outside and then a moat around that. But then you get inside, and where's the king? The king's not next to the drawbridge. The king is like in the middle section of the castle, and the middle section is also protected. It may have an additional moat, or it may be high up. You got to get way up in there, or it has different towers. You know, so you have different layers of security, and that's the approach you use. Is you want to not just look at the outside, but also what are we protecting on the inside. We do that by putting equipment on different VLANs and deploying firewalls inside the data center so we can protect, you know, our data. Yep, there's a good, yes, layered security, Nicholas said, layered security. We want to set traps to help detect intrusion and attempt intrusion. Tools such as OSEC, Bro, Snort, and John the Ripper keep you abreast of potential problems. John the Ripper is really a password cracker. One of the things that I did at one company is I actually wrote a script, and that script ran a program called Crack, and it would constantly try to crack users' passwords. And if it cracked them, we would then send a message to the user that they had 7 days to change it, that it didn't meet our corporate policy. Okay. Seth, DMZs protect, you know, they're kind of in the middle. A DMZ is where we want to provide services like a website to, you know, the public, but we don't want that, you know, that network in our internal network. So we set up a DMZ. It's a layered approach between, you know, our internal and public, and usually we'll have two firewalls. One from the internet, so we can close down all the ports going to the DMZ, except say port 80, the port that we want. And then we can also have a firewall from the DMZ to inside our company, so that we can only open up, let's say, a single port to the application layer. And then from the application layer, a single port to the database layer. We're going to monitor reports generated by security tools. You're going to teach yourself about system security. Yeah, you really, this is a full-time job, right? It's funny, but believe it or not, in my day, there really wasn't some team looking at security of the information technology side. Yeah, you had security maybe to guard people from coming into the facility, but now you have, you know, a virtual security team, virtual because, you know, they're physically not, you know, at the door, you know, for information technology. You know, they're online looking constantly at digital footprints to try and figure out if, somebody's hacking. They look around for unusual activity. They investigate anything that's unusual. Now, here's the thing. Old log messages, changes in activity, they don't prowl around, okay? There is too much data to prowl around. You aren't going to have a full-time employee. What are you doing? Oh, I'm just prowling around, seeing if there's any suspicious activity. No, you don't, okay? It'd be funny. I'd love to have the author here and I go, really? You're going to prowl around, okay? Terabytes of data. What is your job? I prowl around with terabytes of data. No, what you have is a monitoring tool. And the monitoring tools nowadays, folks, they're not simplistic. They have artificial intelligence with it. Okay. Yeah. They're using AI algorithms to look for deviations from the norm, abnormal activity. We have computers that look for unusual activity. So I would say monitoring tools, utilizing, AI for, looking for unusual activity. Okay. Have patches been installed? That's the biggest thing too. Yeah, you want a regular schedule for installing patches. You want a change plan that documents the impact. Here's the thing with patches though. It takes due diligence. When you deploy patches, normally in most organizations, you do it in a lower environment, a non-production environment, and you patch the systems there so you can test to make sure it doesn't break the software. And then once you're sure, okay, we deployed these patches, the application still works, you move it into production. It's usually the job of the application owner. As administrators, we would notify those application owners and say, hey, we're fixing to deploy patches. Here's the latest patch release. And it's up to them to check and see if that's going to affect their application and notify the sysadmin team. An understanding of what patches are relevant to the environment. Administrators should subscribe to vendor-specific security mailings, lists, and blogs. It's a lot to keep up with, folks. A lot. That's why you're not going to be prowling around. Other items we can do to lock down security. Password aging, password complexity. Don't allow blank passwords. Utilize sudo. Sudo allows us to elevate a user's privileges. And sudo will actually keep track of, it's a program that you run on the system called sudo, and it allows you to track what the user does. It's not just, allowing a login, okay? It's also, we can give specific commands that they can execute with elevated privileges. Now it says don't allow group logins. We always allow group logins. Why? Well, because we have what are called, really service accounts, which are group logins. So as an example, you may have a web server running and you don't want it being run under, an account name called James, or a group name called James's group. Usually you would pick we call them service accounts, and you would basically have a service account called web or web server, and you would have a group called web or web server. And what you would do then is you might have this account that would basically run the Apache software, and it would be run as web. You don't want to run it as root, because and here's a biggest mistake that companies make. Biggest mistake is, and by now, because we've had a lab on it, you should know what the Apache web server is, but we don't want that Apache web server run as root, okay? Don't want it running as root, because if there's some security vulnerability, that security vulnerability is as root. So what we'll do is we'll have that Apache software, which, remember, it's going to be running an HTTPD process, okay? And the owner then will be something like web, and the group might be, web server. Now, you're going to have a team that maintains this web server. installs the latest patches on it, installs the latest versions on it. So what we do is we allow them to go sudo, and we can do su minus, and we could do, web. Okay. So that they can switch user to the web user. And there's other things. A lot of times you don't need, you can type in sudo and web, or I could type in sudo and some command. There's a lot of different ways you can configure sudo to do what you want to do. But the important part is that you're not going to allow, when they say allow group logins, nobody's going to know the web password. They won't know what it is. They won't be able to use it. We force them to use sudo so that a user, and what happens is this, you log in as J Wade, and in J Wade, I then have to sudo to web in order to get into that web account. And then sudo will track it. They will log it. We want to make sure we use standard shells like bash, and we want to limit root access. We do that by using sudo. Now, there are different types of security modules. One of them is called PAM, Pluggable Authentication Module. It implements authentication for systems. It has modular controls, has shared library routines that programs can use when they want to offer logins. PAM configuration is in the etc pam.d, and there's a pam.conf for Solaris, HPUIX, AIX. So here we go. If you look, you have the login service, and the login service uses for authentication. Here, look at this. See, these are keys. We can use keys. We can use credentials and authorizations. These are libraries to log in that are used. Okay. Control flag specifies how modules can stack or interact to produce an ultimate stack with that pluggable authentication module. Okay. Here's some of the PAM control flags. So, for example, required. Failure causes it to the stack to fail, meaning some application wants users to be able to log in. Well, they're going to integrate with the pluggable authentication module. And then what ends up happening is, well, it's either going to fail. You can go put these flags for that application and say, okay, it's required, meaning failure causes it to fail. Or requisite, same as required, but it fails immediately. So it may fail a process and send you a message saying, sorry, you can't log in. Okay. Here is a detailed Linux configuration example. etc pam.d, the login file. This is from SUSE. Notice here that if we want passwords, well, here we go. It's going to use the password check, and it is going to do password authentication. What about the session when it negotiates the session when the person tries to log in? Well, there's limits. How many times can they log in with the same account? What about UMask? UMask is where you set that default mask for when you store a file, right? Are we going to give it, read write privileges or read write execute privileges as a default? Okay. Here, the last log is going to track that's for logging, who logged in. There's mail. And so all of this session, and here's authorization. There's a library that's not going to allow login if it doesn't meet certain conditions. So the PAM, Pluggable Authentication Module, is there for programs to integrate with and use for access and login to the Unix system, and of course that application. Set UID. This is where we set ID, and we use that. See, notice right here, it's usually read, write, execute, but you have another one right here that allows me to do a set UID. Now, what is set UID? Well, let's say I ran a script. I wrote a script, and I wanted to give that script itself elevated privileges when it was running. In other words, when someone executed the script, I wanted it to be able to run as root. So if I set, and here you're doing a find minus user root, minus perm, minus 4000 print, and then mail it, set UID root files. Okay. So runs is the user that owns the executable file. Password command to reset your password runs as root, and because root owns the password, and show files. All they're saying here is that when a program runs, like the password, we do set UID. Well, it's going to run as that user, but we do the set UID so that it has basically root access. I could take any script file, set the UID bit as, of course, you got to be root to be able to do this. I can't do this as a regular user. I have to be the administrator. I have to be a root, or I have to have sudo that would allow me to do it. What that means is if I set this bit, if I set it to 4000, it's going to allow me to execute something as root when I run that program. Change root is another one. This combines a process to a specific directory. Folks, this is kind of like remember we discussed containers and how a container does what's called jailing. It actually, if we had root administration on a box, we could go into that directory and see all of the container files. But if somebody logs into the container, they wouldn't be able to see any of the other containers, any of the other data. They are stuck in this single directory. Well, this is how Unix does it. It does it with change root command. A lot of times we'll do this for a web server account, like the web user, so that we can make sure that if somebody does get in a backdoor using the web server, well, they're only allowed access into the directory. They wouldn't be able to go into other directories because we've jailed them into it. We've confined that process to a specific directory using the change root. So you want to run a non-root daemon process like Apache or bind within a file system. If the daemon is compromised, well, the attacker will have will only be restricted to the subtree. That's why you don't want to make Apache running as root. Biggest security mistake folks make. I go look and I'm like, okay, you couldn't have spent a little bit of time, and made sure this isn't running, as root. And man, you'd be surprised in data centers how often they'll give temporary root access using sudo to somebody so they can load their software and they're running it as root. And you're like, seriously? All it takes is a back door that somebody's left from that vendor and they're in that system as root. You're supposed to run all applications on a Unix system with a service account, a specific service account, and even on Windows. Same thing. If you're running that as administrator, okay. Now I will tell you this: it's harder on a Unix system. It's harder on a Windows system to separate away from that administrator account. Okay, to load your software. But on a Unix system, it's not. We just set up an account and a directory and say, okay, log in as Apache. We could make the user account Apache. Log in as Apache and load the software. Okay. But the whole change root is to make sure when we run this command that we are jailing that user to a specific directory. So change root can only protect you, though, if all processes in the chain root jail run without root privs. Processes that run as root always have the ability to break out of the jail. You're not using set UID root execution within the jail, meaning that we went into the directory that you jailed that process to, and you decided to set one of them, the programs or scripts in there as set UID. Well, you just broke that, right? Change your environment is up to date and minimal, and it only contains the executable libraries and config files that are needed to support that program or that task. Network port scanners like Nmap. Nmap, we can scan for open ports. Security teams will often run some type of program to basically scan open ports to get an idea of what they need to lock down. They'll run programs like Nessus, which will also look for security vulnerabilities, or OpenVAS. If you've had, let's say, well, at least if you've had the intrusion detection class with me, the students run Nmap. Also in the intro security class, they run, I have them run Nmap. And they also run, basically Nessus and OpenVAS, which is a vulnerability scan. It looks not just for ports, but when it finds a port like, oh, here's HTTP, it's open, it tries to see if there's any known vulnerabilities. Can it discover the version of the web server? Now that it knows the version, let's look at the database that has a bunch of signatures and see if there's any known vulnerabilities, and let's try those vulnerabilities, those hacks. So here we go. Nmap, we're just doing a scan and it's showing port 25 and port 80 are open. These are just different items that I can utilize with Nmap. Here, look at this. Shows me the version of Linux potentially it's running. Shows me the, right here, the exact Linux version. That's great. Now I can, so from one of these ports, either 25 or 80, it got the actual Linux version. It also got the exact version of, it's using light HTTPD, which means it's not using, it is not using Apache, okay? It's using a different version, but it's got the version. It also tells me it's running SMTP postfix. So it's giving me the mail server version as well. Not the version, but the mail server software. So one of the things that we do with security is we lock down our HTTP server so it doesn't give any of this kind of information. We don't want it to give it whether it's patchy, and we don't want it to give it the version. We also don't want it to give it, what software it is, like for our mail server, postfix. That all of this is a process called enumeration. It gives a potential hacker information that hacker could potentially use to try and, hack in. Other tools like Nessus, this used to be pretty big, but now used to be open source. Now it costs money. You can get a educational, like about 10, what anybody can get, and it'll let you scan 10 systems. But their open source competitor is OpenVAS. OpenVAS actually started as Nessus, and then when they started going commercial, they split off, and basically they have OpenVAS, where it also has thousands of plugins. John the Ripper, this is software that tries to crack passwords. As a matter of fact, in the intrusion detection class, if y'all haven't had that, I'm teaching it again next semester. This is like the last lab where they use John the Ripper, and I actually gave them the shadow contents of a shadow directory that I had modified a little bit so that they could then try and hack it. And here you go, John, etc shadow. And look at this. It found J. Smith password and T. Jones bad password. Okay. So these are this is what John the Ripper was able to, to hack and unencrypt the password. There is a file, two files, host.allow and host.deny. We can actually go in there and say what IPs can and can't access the system. Okay, here, look at this. We can say, okay, SSHD, anything on the 192 subnet, 192.168.0 subnet can access this system. I could lock it down even more where I could only say, okay, only specific systems are allowed and everything else is denied. Bro, the Programmable Network Intrusion Detection System. It is a host-based system that I could load to detect for intrusion attacks, and it would alert us. So it's an open source network intrusion detection that monitors network traffic and looks for suspicious activity. And I apologize, this is a network one, not a host-based, but they have host-based as well. So it detects systems used as stepping stones by checking inbound and outbound traffic. Detect a server that has a backdoor installed by watching for unexpected outbound connections after an inbound one. Detect protocols running on non-standard ports and report correctly guessed passwords. Another tool we could use is called Snort. I haven't used Bro, but I have used Snort. This is also another intrusion detection software. It's available as source code. Commercial support is available from 3rd grade. It provides rootkit detection. So Snort runs on your system. It is a rootkit detection. It checks file integrity, looks for log file analysis, time-based alerting, and active response. It's a host-based intrusion detection system. Hold on just a second. And that is OSEC. OSEC is a host-based intrusion detection system. I've run Snort. Snort also runs as on a Unix system, and it can detect intrusion detection as well. Okay. So you've got several pieces of software. Bro for intrusion detection. I haven't used this one. Snort, I've loaded this on Unix systems. OSEC, I haven't used this one. I've used mostly Snort. The other thing you can use is some crypto tools. I've used PGP, pretty good privacy, to encrypt email. And we've used it to encrypt files that we want to send to a customer. Now, the only downside of PGP is you agree on a shared key. And how do you get the shared key to them? So if you're emailing an encrypted email or something in the email, the attachment is encrypted with PGP, well, you have to send the share key to the other person so they can decrypt it. Usually we send it in a separate email, or we might instant message them, or we've also phoned them up and given them the shared key. Kirbos is a unified approach to network security. It attempts to address some of the security issues. It's an authentication system that guarantees users and services are who they claim to be. When you use something like SSH or some type of service to connect to another Unix server, it's using Kirbos to ensure that that user is allowed access to the service, okay? It uses ticket exchanges between the two in order to kind of issue a ticket and on one side, and then you use it on the other side. SSH, well, that's what we encrypt. Before then, folks, I used to use RLogin, RCP, even Telnet. Before, when a lot of Unix systems, you didn't have the internet. Before the internet existed, we had network connectivity, but it was inside the company, didn't go outside the company. There was no internet. And so what we would do is we would use RLogin, RCP, and Telnet. We didn't have to encrypt. We're in our own company. And then after the internet came out and you had external communication, they started disabling any unencrypted like RLogin, RCP, or Telnet. But it still amazes me that FTP is still out there and used quite a bit. And it's used for, it's unencrypted, FTP is. SSHD, that is the daemon that runs so you can SSH and log in. It has a config file, of course. You also can generate your own public and private keys with SSH, okay? So that you can then distribute those public keys to another server, and you can SSH in. You can write scripts a script that will go out to every server. And if you've got your keys set up properly, you don't have to log into every server with it. Okay. There's a directory in your home directory called .ssh that has your keys. So here's the SSHD file. You have site-wide client, server, prime numbers. You can give them, okay, what kind of keys do we want to generate for those private and public keys? You also have, here we go, add keys to agent. We can automatically add keys. We can have connection timeout information in that config file. We can do some, put a marker in there for a host alias. And we can do server alive where we can ping for connections to the server. And so here we go. Here is, SSH, where really SSH tunnel, you're creating a secure tunnel between port 22. Okay, between port 22. RDP is another, secure remote desktop from Microsoft. And it allows also, it does kind of an SSH over secure tunnel, but you can't RDP into a Unix system. You have to use SSH. We don't use GUIs. There are programs you can run on a Unix system that would give you, let's say, access to it, other than SSH. So SSH uses keys which have to be created. You have to type in this SSH key generation program. Give me 2 seconds here. Is my putty. Looks like it always disappears somewhere. So I'll bring up Solar Putty. Problem is, I think with Solar Putty, give me 2 seconds, folks. I'll pull down Putty again. I'm going to download Putty really quick. And I'm going to log into our Unix system. Okay, so I'm going to show you a little bit. Here we go. So I'm going to move .ssh to .ssh .original. And so now I'm going to do SSH-keygen. And it says, enter the file you want to key. You'll notice the .issh right here. This is the directory it's going to go in, home jway.ssh. It's going to generate my public and private RSA key. And it created the directory. It's now asking, do I want a passphrase? Meaning you have to type in, kind of some like a password. I usually don't, just because if you want to SSH to all the machines, you're going to have to enter the passphrase every single time. Okay. So here we go, .ssh. See how it generated a public and private. Okay. Hold on. I'm going to bring up another putty session. I want to bring up 2. Give me 2 seconds. But notice how I have the RSA. This one here, this one is the private. This one is the public. And if you look at this, what is it? There we go. Now I can distribute this public to other systems, and then I would be able to SSH right into them, without typing in a username and password. So it's pretty cool. So hold on a second. Okay. So it's pretty cool. That's pretty quick how you can generate a key. And if I do a, there's my private key right there. See, it says private key at the top. Why am I showing you that? You know, and there's the public. Why am I showing you that? Well, because I'm going to get rid of it and I'm going to move my old one back. There you go. So I just moved my old one back so I could show you what the private key looked like. And now it's got a different private key. So, okay. So that is how we generate keys. Now, once again, what do we use these keys for? Well, we can put them in. It's also another way that, you know, you can put it, somebody else could use that public key to communicate with you. Okay. But it's really designed for, you know, just logging into other Unix systems without having to, you know, basically type in a password, so you can have a script to go automatically into it. IP tables. A Linux firewall is usually implemented as a series of IP table commands. Notice IP tables here. Let's go take a look at some of those IP tables. Here's some of the flags. I'm not going to go over every one. But what are IP tables? Well, some of you should have had a routers course, but what we do is it's the same as an access control list. In other words, we can say what IP addresses we want to block. We can also use ports to designate what applications that those IP addresses are allowed to access. So take a look. Here I can say accept, accept, accept. I can give it a specific IP address. So I'm saying this IP address is allowed to SSH into this machine, port 22. This IP address is allowed to access port 80, a web server, and this IP address is allowed to access port 443. Okay. I can also, look at this. I can say, well, can they ping or can they do trace route utilizing specific ICMP types? I can designate what they can do with ICMP, whether they can ping is denied. And I can go in and set up IP addresses. I can also do, if you look here, by source port and destination port, by source port and destination IP. So I can do source and IP, source and destination IP, and source and destination port, which is a exactly how a access control list works on a router, okay, or a firewall. Now, funny story. I was installing, I think I told you this, we discussed Puppet, but I would go in and use these commands to open up the ports to the software I was installing. Puppet would come in right in and right over me after about 10 or 15 minutes and put it back the way it was. In other words, it would remove my, I was opening up port 8080 and 8081 with a command similar to this. And then what ended up happening is I got about 15 minutes of functionality, and then Puppet would come in right over it. I had to get with the Puppet guys to basically go in and make this command permanent for those servers that I was working on. Okay. So IPF manages rules and filter lists. IPF stat obtains statistics about the packet filtering. IPMon monitors log filter information, and IPNet manages those network address translation rules. So these are some of the main commands that we would use. And see right here, pass in quick proto from any. And so now I'm using, from any. In other words, the source IP address is any. And going to, okay. So, and oh, by the way, these are IP filter commands, and these are IP tables. There's slight difference in that. they've actually changed the commands with different versions of as they progressed. So there are different commands. You're going to see that because we have a lab, and the lab is going to be slightly different. But you have IP filter or IP tables, okay? And the commands are slightly different, okay? Want to make sure I clarified that. So, and here we go, port 80. So we're basically allowing anything on the 10 subnet to access port 80, 443, and 53. 53 is DNS. Certifications, well, you have the CIA triad where confidentiality, integrity, and availability, meaning, you are, this is a common CIA triad's been out for quite some time. Confidentiality, you want to make sure that that only the people you want to have access. Integrity, you want to make sure that it hasn't changed, unless someone's allowed to, but you want to make sure it hasn't changed. And then availability, well, it's available for the users that need that particular data. They do have certifications. As a matter of fact, I taught this course over at St. Edward's, the CISP, Certified Information System Security, Global Information Assurance Certification, Certified Information Systems Auditors. There's a ton of different secure certifications. The CISP here, downside of it is you have to work in the industry before they give you the certification. So you can pass the test, but you also have to have documented experience. Now, that documented experience doesn't mean you have to be on a security team. It just means you have to demonstrate security functions that you've done. And usually you get a manager's recommendation, and it has to be in certain areas of CISP. There's different areas that you, okay? ISO 27002, International Organization for Standardization, has information security standards for policy to physical access control. The payment card industry data security has PCI DSS standards. NIST 800, the National Institute of Standards and Technologies, well, they have the 800 series for computer security. Common criteria, standard used to evaluate security levels. OWASP, Open Web Application Security Project. Matter of fact, I have labs on this in the intrusion detection class. This is where they have software that will scan web-based applications to see if there's any vulnerabilities in the web applications themselves. So, what now? You've been attacked. Well, don't panic, okay? The biggest thing is make sure you have all the data. Decide on an appropriate level of response. No one benefits from an overhyped security incident. Proceed calmly. Hoard all tracking information. This is a biggie. You want to make sure you have files and logs. And as I said before, a good monitoring system will already have this information and stored in a database. Assess your degree of exposure. And then if you have to, pull the plug. Unplug the system. And what's your recovery plan? Hopefully you have backups, because the only recovery plan that you're going to have is backups if it's bad enough. Communicate the recovery plan. And by the way, this recovery plan, and I haven't asked any questions because I've been lecturing, but let me ask you a question. Yes or no? Should we have a recovery plan planned out ahead of time? What do you think? Yes or no? Lisa, a first level security cert. There are lower level security certs. We teach classes on that. Intro to Security, as an example, looks at the A+ security certification. But you also have that CISP. As a matter of fact, I had guest speakers come in from one of the military bases, a company that worked for the Air Force bases in San Antonio, and they were looking for people to get their CISP. Matter of fact, they would pay for their CISP, give them the training, and of course, if you didn't pass, they gave you 2 attempts. They would get rid of you. That's the downside. But they were hiring people right out of St. Edwards. That I had, a student or two that basically went over there and, but if they didn't pass on their couple attempts of taking the cert, but that's what the company was looking for. Okay. Yeah, you want to have all of this disaster recovery. You want to have incident response plans. We actually, folks, teach a class on that. We actually have an incident response class that we teach here that teach making these plans before it happens. You need to know your systems and networks better than anyone. Yeah, you gotta have really good people that know everything, and eventually you have to report the incident. And you're going to want to make sure you have names, hardware and OS versions, patches, and a list that have been applied. You basically, when you read this, everything, you have to have everything documented because, and you need to know everything. What versions of software do you have? What patch levels do you have? What equipment do you have? What is the serial and model numbers of the equipment? Everything has to be documented and stored off site somewhere where you have that information readily available, including backups. Because an incident can lead to a disaster. And that's why we do incident and response planning. That's one of the classes we teach here. So, sources of security information, you've always got to keep up, folks. You got to understand what those cybersecurity alerts are out there. You want to get on mailing lists like US CERT, Carnegie Mellon University. Okay. In response to the uproar over the internet worm, DARPA, the Defense Advanced Research Projects Agency, formed CERT, Computer Emergency Response Team, to act as a clearinghouse. You want to get on their mailing list if you're responsible security. You have securityfocus.com and BugTrack mailing list. They specialize in security news and information. Securityfocus.com. SANS. Now, I used to be a member of this years ago for the systems administration and networking, not necessarily the security, but SANS stands for the Security Admin Networking and Security Institute. It's a professional organization sponsoring conferences and training, and as well as publishing security information. It's a useful resource that occupies something of a middle ground between security and CERT, and I'm going to say sysadmin as well, because that's why I joined it. Originally, it was mostly sysadmin and networking. Shiner and Security, blog, valuable, entertaining source of information about computer security. And then, of course, there's the vendor themselves. The vendor are going to have this information as well. Folks, that's it for this chapter on security. There's a lot to security. We teach multiple classes on security. We have cybersecurity programs, okay? We have a operating system security class, an introduction to security class. We have intrusion detection security class. We have forensics security class. We teach tons of security classes. You can't teach this in one chapter, okay? So there are other classes out there. And by the way, this is a pretty hot career if you are going into cybersecurity. Why is it a hot career? Because everything's getting hacked into, right? So, okay, any questions? Answer no in the chat session, or feel free to ask a question. Okay. Well, give me a second here. Hold on. Let's see. That was chapter 27. Chapter 28, monitoring. Okay, folks, I think we're going to take a break here before we go on. It is almost 10 o'clock. So let's take a break let's take a 10-minute break. Okay. Easton, what resources are for security around? You know what, Easton, I don't know container specific, but when we do security on a container, we really do it just as if it was a regular system, meaning that we would install, well, first off, the container itself is going to have some kind of application. So there's software already out there that scans the application. Okay. The other thing is that the system that the containerization is running, so Docker as an example, or OpenShift would be running on, say, a Unix server. We would already have host detection software and intrusion on the system at the global level. Okay, so there's when you do containerization or VMware, doesn't matter either one. You look at it from a global scale, meaning the server that is controlling the containerization or the server that is controlling the VMware. And then you look at it from an individual perspective. From VMware, you would have in that virtual machine would be security software. And then in the container, I'll be honest, I haven't seen anything deployed into the container other than monitoring tools. You can monitor. So we could deploy a security monitoring tool in it. It's just that containers are usually designed to be so small, okay, because it's only running the application and sharing the OS. So it would be better on a container to monitor it from, you know, a global perspective. But it's a very good question. I haven't looked at inside containers myself to see what they're doing for security monitoring. Okay. So let's take a 10-minute break. It is almost 10 o'clock, so 10:10. I'm going to pause the recording. There we go. Okay, let's start the recording. So let's see. Easton asked me a good question. Here you go. Everything you wanted to know. Guide to OpenShift security. OpenShift basically uses containers, uses Dockers on the back end. Look at this. They'll give you a free guide right there on security. Here's sysdig. Securing cloud applications on Red Hat OpenShift, which is containers. Oh, look, download the guide. They're just hoping they can sell you something. Container security guide, OpenShift. How to evaluate container content and sources for vulnerabilities. You know, what are containers? We already discussed that. Container security. Securing the container platform. I mean, when you look at, because this is going to be running on top of, you know, Red Hat, which is a Unix system, security wise, you know, they're going to have a lot of basic information about securing the system itself and making sure you secure the environment and who owns the processes running the containerization software and who can log in. And then here, this is interesting, how to evaluate your container content and sources for vulnerability, meaning the applications in themselves, you're going to have to potentially use some type of scanner to check the application itself. How to control access to containers. That's just standard 101 Unix login. Although containers have a different process for logging in, by the way, when you use OpenShift. So anyways, there's a ton of information out there online, Easton, if you want to dig into it. Okay, let's talk about monitoring. Folks, there's all kinds of monitoring out there. Tons of monitoring. Okay. But real world monitoring systems vary in every possible dimension. And it's true, there's security monitoring, you know, they monitor all kinds of different machines that are out there. But basically the main purpose of monitoring is raw data is harvested from systems and devices of interest. Monitoring platform then reviews the data and determine what actions are appropriate. Usually some administrator has set a rule, and then the raw data and any actions decided on by the monitoring system flow through the back ends to take appropriate action. Real-time metrics. There are typically members. It's responsibility of the monitoring system to test these. Now, When we talk real-time metrics here, okay, often they'll also say live metrics. To some point, there is no real-time or live metrics. Now, let me ask you this. Why do you think I say there are no real-time or live metrics in reality? There's a reason that I say that. Anybody? Yeah, Seth, the computers are very fast, but let's look at data in general. When I have any kind of data, what is the variable? Well, it is time. Okay. So you really can't have real time metrics because what is real time metrics? That's right, Lisa. The data has to be gathered. It's after it occurs, not before. We don't have at least not yet. We can't see what the data is going to be before. Now, they can run algorithms, right, to do predictions. But real time metrics, what is real time to you? It's based upon some type of time period. Is it 1 second data, 10-second data, 1 minute? Somebody could say, oh, well, this is real-time data. And you go, oh, wait a second. That happened a minute ago. That's 1 minute. It's 1 minute data. That's not real. That's in the past. So most data really is in the past. They refer to real time, but that real time is relative to the period. They might say, hey, look, this is 15-minute data. This is real-time data. 15 minutes ago? So what's real time? How about millisecond data? Ooh. Problem is that the more metrics you collect, the more data you have to store. So when you monitor something, let's take CPU data. How often are you taking the CPU data? Every second? Once a minute? Every 5 minutes? The other problem is what does CPU do? Well, it fluctuates, right? Looks like a graph. So then the other question is that data relative to you? If you take a data and the sample is too quick, like let's say I take 1 second data, and so I have CPU going 1 second, 1 second, 1 second, 1 second, 1 second, that really skews from a visual perspective. I might get, oh, could be that I'm not getting an appropriate. So for example, let's say this is 100% here, and this is 0%. Now, based upon this, can you tell what the growing CPU, yes or no in the chat session? Based on that graph, if I said to you, well, what's your average CPU utilization? Can you tell me? Yes or no? You say yes, Lisa, you can tell what the average CPU utilization there is? I can't. I would say no. So if this was 1 second data, like this is 1 second, this is 1 second. Remember, you can only see so much. I mean, if I put this into a graph, I can't see like for, real long because it would, no, this is 1 second right here. Each one of these peaks is 1 second. This doesn't really give me a really good, well, yes, you could add it up, but are you going to do that? Most of us aren't going to add this data up. Okay. What we do instead of taking a 1 second sample for CPU, a lot of times for monitoring, we take a 5-minute sample. And so now I get something that looks like this. This is 40%. Now, yeah, I could have taken all of those seconds up and I could have added them, and some monitoring tools will actually do that. You change the graph and it will average it up, but it takes a little bit of a load. It takes a CPU load on the monitoring tool because now it's going, oh, you want me to add all this up? Instead, what we do is when we monitor, we look at the data to determine, well, what should that data be? 5 minutes? That's pretty That's about what we utilize for CPU and memory utilization, because we're looking for that average. We don't care if it goes up to 100%, in 1 second and then back down. We don't care. That's what it's supposed to be doing. Great. It used that CPU utilization. On the other hand, if right here, here's my 100%, here is my 0 line down here. On the other hand, if it's using 40%, that's great. Well, what if it's using 95% every 5 minutes and it's doing it for a lengthy amount of time? Might want to consider, doing our, going ahead and upgrading the system. Events. One of the things that we do is when it reaches 100% CPU utilization, well, we notify somebody or we set an alert. An event takes the form of a log file entry or push, something that notifies us. And then we want to keep some type of historic trend. Is this 40% this, on maybe this is Saturday and Sunday, but on Monday, Tuesday, Wednesday, Thursday, and Friday is running up here. It's 40% because there's no users. Beyond basic channels, the possibilities are endless for monitoring. And you have different types. LED lighting systems that change colors to say, oh, this is green for good, red for bad. You can take automated actions like dumping a database or rotating log files when disk space gets full. You can have it dial an administrator on a phone or sending information to their smartphones. We can also send data to a wall board so that, in a NOC center, a monitoring center, it would be up on a big, huge, 80-inch screen. You can store data in a time series database, meaning a data point associated with a specific time. Or we can just do nothing. We'll just want something to review. The monitoring culture. I've been in this culture for the past 10 years, okay? Doing web-based application monitoring. If someone cares about or depends on a system or service, has to be monitored. If it's production, okay, has to be monitored. If it requires high availability, has to be monitored. Monitoring is not optional. Everything has to be monitored. And monitoring data is useful to everyone. And, okay, all of this is true. I've been part of this culture for years. Here's the thing. You'll get some managers go, well, we're not using that data. We don't need that. So just let's not track that anymore. Let's not monitor that. Sure enough, whenever they say that, because after you've been doing this a while, you know what to monitor. And sure enough, after they say that, it won't be too long that it'll come up and someone will go, well, we need this data. How come we don't have this data? Why don't you have this data? You should have this data, another department. Oh, well, we were told you don't need it. Well, who told you that? And then the manager that said we don't need that. Well, no. I didn't say we didn't need it. I just said we weren't currently using it. I see them. They'll do a 180 backtrack immediately. Everyone should respond to alerts. Good luck. This is an art, really is. If you tune the alert where when they get the alert, it is something they need to reply to, they will. But if you send too many alerts, they just ignore them. Okay? Okay. And then properly implemented, monitoring impacts the quality of life in a positive way. It can also in a negative way, because if you get too many alerts and they're false positives, people are trying to respond to those alerts and they're being called out when there's no problem. So the alerts are fine tuning. You also have to train them to don't just suppress them. Yeah, let's just ignore that. Because then what happens is, if So here we go. Evaluate false, positive, or noisy alerts and tune them so they don't trigger. You have to tune these alerts, okay? So we were looking at performance on our PCs. Yes, you can actually go to, for those of you that have Windows, you click over here. It's in the empty space of your taskbar. You go Task Manager. That Task Manager right here shows you all the processes running, shows you the CPU. You can click on the top here. It'll sort it by CPU. See how all the CPU up here is high? And that's WebEx right here. Memory, who's using the most memory? Malware bytes. Disk, network. This is disk transfer, which process is, is transferring the most data to the disk drive system. This is network, and this is graphical processing. Ooh, who's doing that? Oh, my video camera. And then here, performance. Right here, this gives you all the performance information for CPU, memory, disk. And by the way, this just isn't it as well. There is another one that we can, oops, hold on, let me get it down here. There is, it's on my other screen. There is a program that you can type in perfmon, which is performance monitor. This is another program you can run on your system. As a matter of fact, we run these on servers, and some monitoring tools actually pull this information down. This is called Performance Monitor. All your systems will have it, and you can actually go and click and add. See how it's kind of an empty graph? It's got processor information. But watch this. I can click right here. And this is all, look at this. This is all of the data. And some of it may not have any data, but all of this is, you can basically go in and add this over here to this added counters, and it will give you all this performance statistical information. And we can actually pull this into monitoring tools as well. I've basically written some scripts that install on this and basically would pull in this data. For example, see where it says database information? If you have a SQL database and you do the arrow, well, here's IO database read averages, database cache percentages, and so you can pull all this information from Windows. Okay. There you go. As far as Unix really doesn't have, because we don't use GUIs, okay? We don't have, say, a GUI tool like, this, that we can pull all this data in. What we would use is a monitoring tool, and I'll show you one that's open source that you could load on Unix, okay? But this is Performance Monitor. So for the most part, we use Task Manager to find out what's going on with our system. So you get CPU, memory, disk. Usually I'm looking at CPU going, okay. It also will show you what kind of system that you have. So if you look down here, I got 318 processes. There's no overhead with Unix, but it shows you, look, I got 6 cores. Right here, I got 1 socket. So I got 1 CPU with 6 cores, okay? Meaning 6 logical processors, okay? 6 processors. And then here, memory, well, you can see right on the memory, I'm using 8 gigs, and I got about 16 gigs right there, okay? So this gives us information as to the load on our computer or on our system, okay? And then, of course, perfmon, everything but the kitchen sink. Literally, you can pull, if there's database server, I'll pull database certificates. SMB, remember we talked about SMB when we have share drives? Well, if we have something mounted, we would be a client, or if we're sharing one of our drives, we would have basically the SMB server. I could pull TCP/IP information straight from the network interface controller cards. Okay. So I can pull all of this information, and you can pull it into other monitoring tools as well. That's what we would do. We'd pull this into a centralized monitoring tool. Okay, monitoring platforms. Good news, variety of choices. Yeah, there's a lot. It allows us to gather data from tons of different sources: HTTP connections, SQL database, DNS records, network information, CPU information. But here's the biggest thing: the interfaces vary. Okay, you have customizable GUIs, you have web interfaces, but the user interface, that's the biggest deal with all these monitoring tools. Which one's the easiest? I've worked with monitoring tools where they're very easy, very intuitive to utilize, and then I've worked with some that are just flat out horrible. You're like, okay, where's this at? Okay, who designed this? Now, my philosophy is that if a tool, doesn't matter whether it's monitoring or a piece of software, if it's not easy to manipulate and move around the GUI, then to me, it's poorly designed. Should be a lot easier. One of my biggest things about Microsoft that I dislike is the fact, because I've managed Windows servers. On the Windows servers, we teach a class here on Windows servers as well, but I've managed Windows servers, and every time they come out with a new version, oh, it's 2008. Oh, it's 2008 release 2. Oh, it's 2012. Oh, it's 2012 and release 2. Oh, it's 2016. Every time they come out with a new release, they move the GUI. And you're like, and I'm talking the administration GUI. Wait a second, where's the control panel? Oh, we did away with that. It's now settings. Okay. Why? Why? Seriously. Unix, the ETC directory's been around for years. All you really need to know is the configurations are in ETC. That's it. Now, and pretty much ETC between the different OSs doesn't really change. They might change a little bit, but not as drastically as Windows does. So the next thing you do, you're like, where's the network configuration? That kind of disappeared. Where's this that I used to easily be able to get to? And it's hidden somewhere. Cost. Some commercial management packages can be a stiff price. Yeah, there's open source monitoring tools, and there's ones you pay for. And when it says stiff price, folks, we're talking millions of dollars. Millions. I've installed monitoring tools that cost the company millions of dollars. Automated discovery. Okay. Well, Seth, is it too much? It's all relative as to what do you do for a company. Okay. Is it too much? What do you do for a company? For example, let's say you have an open source solution, but it doesn't give you some of the monitoring tools that I work with, basically work with web-based applications. They actually show developers SQL query issues or show problems. Okay. Automated discovery. Many systems offer to discover your network, and they can go out and build large network maps. Reporting features. A lot of them can generate reports, and they can email them to you. As a matter of fact, I've written scripts that go out, access the system, automatically generate a report, and mail it every Monday. You have software out there called Nagio, Sensu, Graphite. I've worked with Graphite. I've worked with Nagio. Haven't worked with Isinga or Sensu. I've worked with Prometheus. I've worked with InfluxDB. Sorry. I'm going too fast. Haven't worked with this. Haven't worked with Muna either. Here's some commercial popular ones. It's interesting because I look at some of these and I'm like, I've never heard of them. If they're that commercial and popular, why have I not heard of them? Because I've been to a lot of places. Datadog. Haven't seen anyone using it. Librato, nope. Montius, nope. Pingdom, nope. Signal FX, I have heard of this one. SolarWinds, yep, heard of this one. SysDig, Cloud, never heard of it. Xenos, never heard of it. Okay, so when investigating commercial monitoring platforms, you have to consider the price. how easy it is to integrate, and how much of it can your infrastructure, how much of it can it monitor? What is its full functionality? How does the system deploy new plugins or check-ins to the host? Does it integrate well with any existing platforms you might be using? And does your environment allow the type of external connectivity needed? Okay. And so there's also a lot of commands on the Unix side, and you have to know these commands. Okay. Let's see. Easton asks, do config managers like Chef provide monitoring out of the box? No, they don't. And Chef is more of a configuration management tool, not a full-fledged monitoring. And here's the other problem with monitoring tools. Monitoring tools start with different functionality, and then they try to add the kitchen sink. That doesn't necessarily mean when they added the other functions of the sink that it works that well. Here's an example. You go to a company that they started out monitoring databases, and their software is the best for databases. And then they started saying, well, let's add in applications, Java applications that communicate to the databases, or PHP, or some other type of software. And guess what? It doesn't work that well. Their application software monitoring is kind of crummy compared to somebody that started on the application and then they pulled in the database. And their database product's crummy. So a lot of times you'll get companies that'll look for best products, okay? And they'll go, okay, this is the best database project. This is the best application monitoring project. And they'll try to then integrate them into a central view, okay? The other thing, so all of these commands here, some monitoring, open source monitoring tools, they just use these. By the way, these commands are commands that I would expect you to know on the Unix side. If I was hiring you to do some Unix administration, I would ask you, well, how do I check, free and used disk space? How do I check directory sizes? I would ask all of that if I was going to hire you. For example, let's take a look at these. df. Notice, and I'm going to do a df minus h, and I'm going to grep minus v. I'm going to get rid of this temp. Notice, tells me the size is 3.9 gig, and I have 3.9 gigs. So this is just /dev. They're mostly links. Here's the operating system, the / the root level. 28 gigs, 21 is available, 5 is used. Here's the home directory. Available 68 gig, used 85, and the size is 161. We can take this information, and there are open source tools that use this command to monitor disk space. How about we go to home, we do a du minus s of J Wade and see that, I got about 388 megabytes, 388 megs right here, J Wade. This is a way to understand the du command. It gives me directory sizes. We utilize this command to try and figure out, okay, J Wade has 300, well, which ones? Well, see, watch this. I can change into J Wade. I can do a du minus s of star, and it'll give me all the files and the directories and the sizes over here to the left. So here we go. I've got my backup tar that's 196. Old has about 25, but this is the biggest one right here. This is how users would use this command to go down and understand where all the disk space they're using is taking up. Free, let's see if free is available. It is. Free is basically looking at our virtual memory. Okay, so memory, swap, used. IO stat looks at disk performance. And And it looks like IOstat isn't in here. That's a command I haven't. It's pretty much been on every Unix system I've ever worked with. Interesting that it's not here. I think they're using, if I remember correctly, I wish they would use Red Hat, but this is Debian. I think it's GNU. Yeah, GNU Linux. LSOF, it looks at all the open files. So these are basically open files. Sometimes you can have a file that's opened and so big and it's actually what I call invisible. You can't see it. You do an LS, you can't see it, and it's got some huge open file that's filling up the disk space. We use that sometimes also to find disk space. NP stat. Nope, doesn't exist on this machine. It does look at per processor. VMstat, that should be there. It's on every machine. Oh, it's not. Oh, I typed it in wrong. Yeah. VMstat, if we look here, and all of these commands you should know. CPU, this we look often with VMstat. Notice it has wait time. Okay. Actually, that's idle time. Idle time's 100%. Wait time. And hold on a second. Normally, when you do VMstat, VMstat initially, you don't do it just once like this because these numbers won't be right because it's doing it right then, like exactly. So what you're supposed to do, if we do a man, you can do a man of any one of these commands. What you're supposed to do is the delay and count. How many times do you want to do it? And basically, how long do you want to, do it as well? So as an example, hold on. It's got the IOstat there, but let's see if it's in. Nope. Huh. Wonder if he accidentally deleted it off this system. So see, you got the sampling period, which is delay. And usually with VMstat, we'll run a sampling period. So let's do a 3 and a 2. So see how this comes back immediately? Well, that's not a sample. So really, we kind of ignore the first one. Let's go VMstat 10. Let's do 3. So 10 seconds. And it's basically taking a 10-second sample, which is really still, usually we do 5 minutes, actually, to get an average. So see these zeros down here. This is wait time. This is idle time. Then here you have sys. This is the amount of CPU time that the system's using. Here's user, and here is, basically the user, the system, and the idle time. And I don't remember, this is like in and out, and I have to go look some of the IO because I don't remember. Oh, this is swap. That's right. This is swap. This is IO right here. This is memory statistics right here. This is buffer, cache, and free. Now, here's what's interesting is that with Unix or Linux, it will sometimes you'll look at the memory and you'll go, wow, there's not a lot of memory left. Well, in actuality, you'll see this cache will get big. It's building a disk cache for IO to improve IO. It'll use part of memory to free up, and utilize it as a disk cache. If it needs free memory for the program, then what it'll do is it'll grab it from the cache. Okay. And it has the ability as well for the buffer. Okay. So these different commands we utilize for, when a system has problems, we log in and use this to try and figure out what's going on with the system. But we also can pull this information into a monitoring tool. Log monitoring, we have log monitoring tools out there like Splunk, which act as a log aggregator. That's how they got started, was, doing log aggregation. And once you had that data, you could pull it in. SNMP, Simple Network Management Protocol. Yeah, tar is like zip, but on the Unix side. But Unix also supports zip as well. SNMP, Simple Network Management. So they started out where all these routers and switches and networking equipment, they wanted to be able to manage them remotely and also pull statistics from them. And so each one of these had what was called a management information base. It had a little MIB file, and the MIB file said these are the statistics that you could pull from it. Okay, these are the stats you can actually pull from it. You could pull CPU, memory, disk I/O, 2 tons of metrics. And it kind of moved, this morphed from just being a network management tool to utilizing it for monitoring tools to pull in all the data. And it wasn't just networking devices, it started being servers, PCs, every device. You know, a printer, SNMP, a plotter, SNMP. All of the devices hooked to the network, you could use SNMP and pull it down. So your centralized monitoring tool would have all the MIBs on their system, plus each system would have the MIB, so they could talk and say, hey, here is what you can pull down from me. So we could pull tons of information. Now, there was programs that you could utilize to basically walk or understand what was available. One of those was SNMP Walk, where we could actually traverse the MIB, that management information base, which was a little file that was really a metadata file saying this is what you can pull down. You had SNMP Get, where you could actually go get the data. Or to manage something, you could actually set something on the other side to manage it. Now, everywhere I've been, they don't really use the management side of the house. They really are just pulling down data, but you could. Okay. And here's an example. They have what's called a OID. Okay. An OID. And that OID is a object identifier. It identifies the actual object that you can pull down, and they organized it by numbers. Let's go take a look. I'm going to pull this down from images. Here we go. So this is what that OID would look like. So at the top, you had root, then you had ISO, org, DOD, internet, and then notice, look, you know, you might have experimental too. So each of the numbers, you know, is basically kind of a label to the data that you can actually pull down. Okay. Each one of them is the data that you can actually pull down. Oops, let me bring that back up. Okay. And, you know, here's another one. So take a look. Root, ISO, org. So you might have a, you know, 0, 1, 3, 6, 1. And I don't see. And then it would be 4. And I don't see anything with CPU on it, but here we go. Here's another one for the OID. And a lot of times this organization up here would be the company that has the data with their device. So their name would be up here as well. So like Enterprise, Infoblocks, Platform, Trap. So all of these IDs are what you can pull, the data you can pull from those systems. So that's an object identifier. And if we take a look, if I use a program called SNMP Walk, well, here's the data that I can actually pull down. Okay. Some monitoring tools come with basically SNMP capability to pull the data down. So here, and a lot of times, instead of seeing the OID, sometimes all you would do would be see the numbers here. You would see the names. So as an example, see, this is the MIB, Management Information Base. sysdescript.0 is the system description. This is a Linux. The server name is called tuva.atrust.com. It's running Linux 2.69.11. Here is just the system name. And all we're doing is going down, and folks, this list is usually long. I used to, with strange devices, I won't want to say strange devices, with devices that we didn't have a monitoring agent. Some companies write an agent, and you deploy an agent that pulls all of this. They don't use SNMP, they use an agent. But there are other devices, appliances as an example, that a company wrote. One of those is called a data power. And you may, with let's say a data power appliance, you may not have an agent you can deploy on it. Why? Because it doesn't have a disk drive. It has, firmware, software, and you want to still be able to pull down monitoring data from it. Well, how would you do that? You would use SNMP, but sometimes, unfortunately, there's no MIB for it, and the monitoring software doesn't recognize the device. And so you have to walk the MIB to determine, okay, what can I pull from it? And you can either pull with the entire OID. Let's see. I don't see it. You can actually use the, entire OID, that number, or you can do, hey, I want if MIB, : if description.2, ETH0. And notice interface type, Ethernet. Here, look at this. Physical address of Ethernet 0, which is if descript.2. Here is the physical address. So you have to make sure, and look at this. Here's the input octets and the unicast packets. And each one, .2 goes to ETH0. And so you have to figure out what the MIB is on some devices so you can pull the applicable information that you want to monitor. Okay? Pull it into the monitoring tool. We have intrusion detection software for security, intrusion prevention software for security, monitoring tips and trips. Avoid monitoring burnout. Ensure that sysadmins who receive notification outside of regular work hours get regular breaks. Yeah. So if you're on a monitoring team, it depends on how they have it organized. On the one hand, they could have organized it where you just monitor and send the alerts to the appropriate people. Those are nice. So if it's 24/7, it's not you, it's somebody else. Like you might not be the Unix administrator, but you're the monitoring administrator, and you configure all the monitoring software, and you notify the Unix administrator. Okay. Actually, when I moved to monitoring, I didn't have to carry a pager anymore. So for years, like 30 years, I carried a pager. And then when I moved at dedicated web-based application monitoring, I stopped carrying around a pager. Didn't have, and a pager or your smartphone. I didn't have to be available 24/7 or on call because I did primarily monitoring, meaning I sent it to somebody else who was on call. Eliminate noise. This is a biggie for most people. You don't want to make their lives miserable. So you have to tune the alerting so that legitimately, if they get an alert, there's a problem. Normally what we do is we send the noise to their email. They can then use a folder to put it in there. Something, okay, you don't need to, be on a Saturday night at 2 a.m, logging in to check on something. But when you get to work on Monday, you may want to check on it. So you look at your email and you go, oh, this doesn't look, maybe it looks a little off. Let me go check. And a run book is when we configure something and then we create some kind of documentation, usually a run book. When I was installing monitoring tools for companies, I used to do a lot of traveling, going to California, going to the East Coast, installing these monitoring tools for them and configuring it. I would leave them with a run book, how everything was configured. We want to monitor the monitoring platform. Usually in large environments, you have a non-production environment where the developers work and everything down is and then you have the production data center. So we have a non-production area of the data center. In some cases, you may have two data centers, two of them physically, geographically located in other locations. When I worked for the state of Texas, we had our non-production center was actually in Round Rock, and our production center was in San Angelo. And so you always do stuff in non-production to test it before you roll it into production. With monitoring, we had two monitoring platforms, one monitoring non-production, one monitoring production, and we would actually have each of them monitor each other to see if, they might go down. Because here's the thing, if your monitoring doesn't work, if you have an outage and it didn't report it ahead of time, or I shouldn't say ahead of time, it didn't report it, well, guess what? Management's going to come to you and go, why did we have to have 2,000 customers screaming at us our site was down? Why didn't we know about it? Here we go. Look at all these monitoring tools that we've got here. Let's go take a look at some of these. So give me 2 seconds. Go. There's one. There's two. See if this one's still around. There's three. And and give me one more. One more. Need just a second, folks. Okay. Let me bring up, I want to show one other thing. I think Seth asked me on the UNIX side, something that was kind of similar maybe to task manager's performance window. Well, in the UNIX world, we have what's called TOP, T-O-P. And TOP kind of does, and I'm going to type this in, TOP into the chat session. TOP kind of does a little bit, but more of a text-based than a GUI based. So you don't get a graph or anything like that. But you can see that when I type in TOP, tells me that the system's been up for 183 days. 5 users are logged into the system. The load, here's the load app. So there's no load on the system. Look at it. It's less than 0.00. And then here I got 139 processes running. Are in total. One's currently running, 138 sleeping, no stopped, and no zombies. We discussed these different process types. Here's all the CPU, 0.2 user, 0 system, nice, and idle time. Here's the wait time. And then here we get memory and swap. And really what we're looking for on swap is right here, this use. And then here's all the processes running. In TOP, there are shortcuts where you can sort by here, percent CPU. You can sort by percent memory right here, percent memory. And then also this is the virtual size in memory of this process. The resident is physical memory, okay? And then here's the actual command. And this is the number of CPU time that it's been running. And of course, our user. This is called TOP. Okay. Oh, did you already say that a bit ago, James? I didn't see that. You know, I'm trying to see as much as I can over there, but I didn't see that. Try to read as many questions or comments that people get. Okay. Oh, there we go. Yeah, I do see it up there. So, yep. Thanks for putting that in the chat session. So, anyways, the other thing is, but in reality, the only time we really use these command lines I've shown you or top is when the system has problems. But here's the thing, okay? We don't go and log into all these different systems. On our desktop, pretty much for the most part, on a desktop, we actually, know when something's going wrong because it's slow. You're like, well, what's going on? But when we manage data centers and Unix servers, you don't know what's going on. You have to rely on a monitoring tools. So here's a few monitoring tools that I have worked with in the past myself. I set this up for the state of Texas, one of the organizations. And it was funny because years later after I'd left them, they were still using this. It was open source. This one started out as Big Brother. That was the name of this. And then it went commercial. A company called Quest bought it, and it went commercial, which was okay. But what they ended up doing is the guy that designed all the GUI for this separated off. He actually started it out calling it Hobbit. Okay. And believe it or not, the Lord of the Rings, the ones that own tokens, the company that owns tokens products, well, they actually told him they were going to sue him if they didn't change the name, that Hobbit was trademarked. And so he changed it to Xymon. I don't know why he called it XY Mon or, XY monitoring. But I mean, because, it's not a name that you would like jump at, but it's not bad for being something that's open source. You have these little lights. You can click down into it. Notice it now shows me systems. Here's all the server names. And at the top, these are the different, what it's monitoring, the data it's pulling. Now, this installs an agent on each system. Okay. This installs an agent on each system. And, if you look at this, if we go to CPU, you can click on the dots. So there we go. And here, what does this look like to you, folks? The top command right there. See the top? There we go, top command. They're pulling the top command into this straight away. And let's see, I've got this too large because you can't see the graph at the bottom. Oh, it's not. Oh, that's right. I remember this. It won't show the graph, I think, with Chrome. I think I had to go into Firefox the last time I showed this for some reason. Give me a second here. Did who pay me for this, Lisa? The state of Texas? I didn't go in there just to set this up. I was basically I was a senior consultant with them. Okay. No, I didn't create this. This was created by another company. This was created by somebody else. I just, I set it up. How it started was I actually worked for a company called Accenture. And Accenture had the contract with the state of Texas, and they actually had the contract with the state of Texas. And my boss came up and said, well, I was in there because of my data center experience. I had a lot of data center experience, and they were having problems with the data center, and they had a company that maintained it. They wanted me to interface between the application developers, the application administrators, the database administrators, to try and stabilize their data center environment. And so the first thing I said was, well, we need a monitoring tool. And they said, my boss said, well, no, we've already got one, use theirs. And I'm like, they won't give me full access to it. And so I installed this tool, and here you go. It looks like Chrome has an issue with whatever they're using. Here's this graph. So they're using top to pull in the data, and here's the graph. Now look at this. This is what I like. You can click on this little hourglass, and you can actually move to the time period you're looking at to zoom in. Okay, so I can just keep zooming in. And so I installed this tool, and the first thing I found was things like, oh, I noticed that some of the RAID drives haven't been replaced. Well, that added, that's pretty big, because if they lose the other drive, these were mirrored drives. Remember, we discussed RAID in one of our other chapters. It was a mirrored drive, and it literally, you basically had it where if one of those drives went out, the system would go down. Now, and these were production systems. But using this, we can monitor all of this. Now, here's disk. Watch this. Now, does this command look familiar? This tool's using DF to show us disk space. Let's go check on memory. And I can tell you what it's using for memory. It's using VMstat. Okay, but here's the memory that it is pulling out, and then here's the graph. It's showing me memory utilization. Now, if I don't want to just, okay, I don't want to go to each one of these, at the bottom, over here at the end, see where it says trends? Well, trends will show me every one of the graphs. I can just go down and look at all of the graphs for this system. And if let's say I had an error, I could go in, because this is historical, it's putting all the information in a database, and I can click on one of these, and I can basically set a particular day. Look at this, show last 2 days. How about we show last 12 days? And look at that, there we go, 12-day graph. Just instantly I can go back in history and look at 12 days. The other thing that this does, which is to me really awesome, is I can go and see this reports. These are reports that we can generate. But the one I like the most is the snapshot report. Oh, why are you blocking this? Blocked. Malware guard blocks downloads that are either come from website really light traffic. I'm going to say do not block site again. Continue to site. Okay. So I can go in here and I can do a snapshot report. Now this is pretty good. Look at this, folks. I can select a date and a time. So you come in on Monday and somebody says, well, on November, let's see, on November 15th, at 2 a.m. in the morning, a user complained that that something didn't work, and I could do generate report. Oh, it's going to give me this download. Oh, that's a bummer. Let's see. I've chosen to open a shell script. Well, what it'll do is, and it looks like, it's not allowing it. Let's just, out of curiosity, let's go back over to Chrome, see if Chrome will do it. And now you're looking at something going like, well, that's kind of hinky. It's not doing some of this stuff. And I would agree with you. But here's the thing is I got a lot of protection on my system. And we would go in and configure and do some configuration. So what you're seeing now wouldn't happen, but it is open source. I think, who was it? Was it Seth that said, Seth that said, well, millions of dollars for a tool is too expensive, but you get what you're paying for. There we go. So you can see I'm going back between browsers, and that works in this browser, it doesn't work in that browser. And I haven't read recently or installed this, but a lot of times when you install a monitoring tool, they'll actually recommend the browser to use it and the version. But take a look. See the time over here? November 15th, 1809. So you can set it. And what it does is it snaps this thing using the data from the database to that date and time. This is awesome. It was an awesome functionality because we would come to work the next day and somebody would be complaining that at 10 p.m. or 2 p.m. some user complained. Or how about this? A user complains, but by the time you get the ticket, it's 2 hours later. And you're looking and going, well, I don't see, everything's green. You know, it's green. Everything looks fine to me. I mean, here it is. Everybody see that? It's green. Well, you can then go back very easily to this report, say snapshot. Well, when was it? Okay. It was, last night, which last night was, let's see. Oh, it was the 20th. Today's the 20th. And it was at 2 a.m. Let's generate a report. Oh, there we go. Yeah, this must be what they're talking about. Okay, let me see what this is. Let's see. And then you click. Okay, here he is. Oh, memory. They had a. Oh, yeah. Look. What is this? Camo's system had a memory problem. Let's see. Virtual memory. Wow, 96%. Look at the physical memory. 95, and wow, it was 48% swapping. Well, we may need to add some additional memory onto this server. What's going on? Oh, they're doing batch processing at that night. Lisa, I don't know what they use at ACC to monitor. This is, once again, open source. You can access this at, all of y'all can access this at, the website in this URL right here. Here we go. https://www.zymon.com, and I'm on there. Zymon.org. That's really where this is at. Okay. And there's a bunch more this thing can do, folks. This is just the tip. You can actually see where it says views here. You can actually have your own little view. So this is the main view. This is all non-green view. Look at this. Oh, right here. See, Saturday at 14:33, November 20th. Here's, it went from, yellow to green and green to yellow. And you can go click on this and see, well, what was it? No system peer entry found. That's it. I don't know what NTPQ is. Okay. Might be a queue server of some type. You can go critical systems. So all of this information, you can set up your own little views here. So see, you got systems here. I click on it. I can set up like just databases. I can set up just app servers. And that's exactly what I did for the state of Texas, so that the database people could look at theirs and they would actually have these up on their screens. Okay. And then there was a little app you could download to your system where they didn't have to have this up. It would monitor just their screen. It would pop up a pop-up box to go red, and then they could click on the pop-up box and it would bring them to their little view. So it's pretty cool for an open source tool. Not bad for an open source tool. Okay, let's go look at some more. Here's Cacti. Cacti was designed, for network information. So a robust and extensible operational monitoring and fault monitoring for users for network grafting. So it was, and let's see if they've got, get more details here. Let's see if they've got some other graphs. Info. Let's give it a couple of seconds. What is Cacti? I'm not seeing too much. They used to have more graphs that we could look at. Here we go. Features. That's more, but this is another one. See, we would actually pull in and it had graphs and we would pull this in order to be able to look at network graphs, cacti. So this is cacti. By the way, all this is the last page of the displays. OpenNMS was another one. Haven't used this one this much, but once again, here you can see that this tool here, and this was open source as well. I don't know if it's still open source, but you can see it can pull up this, geographic maps of where the error is. Okay. And here, once again, you can pull up like a little network diagram. So, and here gives you all this information. Now, notice what I want you to notice is the graphical user interfaces. There's different types of interfaces. Some are better than others. So here you're looking at OpenNMS. Now, another big one here is Nagio. This used to be just open source. It's gone commercial now. Download free trial, request a demo, Windows server monitoring, Linux server, app, and so now it's, they have the professional version that you can actually, take a look. Let's see how they're.
Every day, on every continent, on every team, there are innovations about to be made. Lives to save, minds to inspire, machines to power, mouths to feed, and voices to be heard.
Okay, I'm going to turn that off because it's a fluff piece, meaning I'm not seeing the tool. And it seems like more and more with some of these, they stop doing, something where it shows the tool, or you got to go dig for it, because every class I pull this up and I show, so look at this, UNIX monitoring. Let's go take a look at the UNIX monitoring. Here we go. This is good. This is what I'm looking for, but they keep moving it around every time semester that I teach it. Woo! Okay, there you go. What do you think? So now you've seen a couple of tools here. You've seen the Xymon, which is what I've used. I've also used this in the past. But can everybody understand or see that depending upon the tool, can everybody see this has a more sophisticated GUI? Yes or no in the chat session? Can everybody see the difference between, okay, I've got this kind of GUI, and I have the Xymon GUI that I was showing you a minute ago. Take a look. This, I got this GUI, and I've got this kind of GUI right here. So this is Nagio, powerful monitoring engine. Look at this. Wow. Now, can you understand why, okay, some tools cost a lot of money, and some tools are free. It just depends on what your budget is as an organization. Okay. And so this tool used to be free as well, open source, but it went commercial. And I always think this is funny in that, all of these open source tools that we administrators, and basically we're the administrators that, you're looking at the person and other of my colleagues that tested it out for them. Here you go. Here's a fully tested. Oh, let's add this functionality. and the open source community was programming this for them. Okay. So I wish I had been smart enough, to, it's funny because I look sometimes and go, man, I know all this stuff, but how come I'm not a Bill Gates or, or somebody that came up and said, and I had thought about it one time designing my own monitoring tool, and because I was seeing commercial monitoring tools that didn't go open source that were costing literally thousands of dollars, millions of dollars. And I'm like, man, I could design something like this. It's not that hard. But man, whoever came up with the idea of let's get an open source community to design this for me, and then later on I'll make it a commercial product. So it's let's go look at the pricing. Starting at $19.95. Here's the Enterprise Edition, $3,500. Not a big price, but then the question is, well, how are they licensing it? A lot of these tools, they'll license by the number of agents, like how many systems are you going to monitor? So see, it says starting at, it doesn't say, oh, yeah, you get this Enterprise Edition that costs this. So just out of curiosity, let's see if we can figure out how they want to do it. What level of license? What would you like to purchase? Network analyzer, support options. Okay, so here's if you want to get support. Support means also usually, do you get the updates? Okay, and I'm not seeing here how they're licensing it, but whenever you see anything that says starting out, they're making you think, oh, well, this is a pretty good price. That's not bad for a full-fledged monitoring tool, but wait a second. Where's the, let's see, web-based console, capacity planning, audit. It doesn't say how many agents you are allowed to monitor. So that's what you have to look at, on the pricing when you get to the pricing. Okay, let's go look. That was Nagio. Splunk is that log aggregation tool. Let me ask you, did I show Splunk earlier when we got to application type? Have I shown this? Answer yes or no. Yeah, James, at 3,500 per agent. It could be. I haven't shown Splunk. Okay. So Splunk started as a log aggregator, meaning pulling all of this different logging information in, all of the logs that are out there. As a matter of fact, I wanted this tool for one of the agencies at the state of Texas. They approved it. This was about a $1.3 million tool. And they approved it on my word, okay? So this was 1.3. So Seth, here's one of your monitoring tools. The way they license this is by the amount of data, the amount of log files. And we wanted to pull in all of our log files. Now, I don't know if it's that expensive now, but here's the thing. This tool started out as log aggregation, and then it would build these dashboards, and those dashboards would alert or notify, but it was mostly infrastructure data or application data. It didn't do, and look at this. Once you got the data coming in, what can you do? Look, security, investigation and forensics, security analytics, security operations. Remember our last chapter just a minute ago was security. So now I can pull this information and look at the data from a security perspective. What we used it for, so all of this wasn't up there. What we used it for was infrastructure monitoring and troubleshooting right here. This is what we used it for. But, now when you've got all that data coming in, well, all you have to do is, just use it for different purposes. So let's see. Give me two. There we go. See if they show the tool.
Only 11% of organizations are satisfied
Oh, come on.
with their existing infrastructure monitoring tools, which means most teams are not. Are you one of them? We know that now, after moving to the cloud, you're juggling countless tools. Some are legacy, some are for monitoring,
others for troubleshooting. And when something goes down, troubleshooting becomes a team sport. But since everyone is using different tools, it takes a long time to figure out what's happening. You don't have the visibility you need to know what's actually going on across your entire infrastructure, which means data stays stuck in silos. In other words, it's useless. This is all very time-consuming and, frankly, exhausting, not to mention detrimental to your business. You need a solution that doesn't slow you down. One tool that stays 10 steps ahead. You need Splunk for infrastructure monitoring and troubleshooting. One tool for all your monitoring. With Splunk, you get speed to find and fix problems, scale so you can leverage data from any source, on-prem, multi-cloud, or somewhere in between. Now you have visibility across your entire IT landscape and analytics to catch every problem, even the ones that are hard to find. That explosion of data that caused you countless headaches? Not anymore. With Splunk, you get the industry's most powerful analytics-driven multi-cloud monitoring and troubleshooting solution for all environments. Consolidate tools, simplify operations, break down silos to pave the path for growth and success. Future-proof your investments with Splunk for infrastructure monitoring and troubleshooting.
So you can actually download this tool, free Splunk. As a matter of fact, I did a POC, proof of concept. I actually did a POC with the state of Texas and allowed us to basically monitor 10 systems to, to check this out. Let's see. Give me 2 seconds here. Let's see what this looks like.
Hi, my name is Roberto Bezic, and shoot these vessels, but however, now with dashboard.
Okay, so what I'm looking, I'm not going to do the whole interview here. I just want to see if we can see the tool a little better. Now I've seen it myself. One of the things, so here, take a look here. This is dashboard technology, and I'll tell you what a lot of companies are starting to do. They're starting to do Splunk for aggregation of other monitoring tools. Just because they're pulling in log information, they also started pulling in from data from other sources. Doesn't mean they're the best tool for monitoring databases or web-based applications, but their dashboarding technology is pretty cool. And so a lot of the companies that I've been working with over the past few years have been using Splunk to kind of aggregate the other monitoring tools. You still go to those monitoring tools to do in-depth dives, but they're doing, log aggregation.
To display data about complex process and scenarios in an easy way. Dashboard Studio has taken visualizations strides further, supplying the user with graphical enhancements and native capabilities for customizing dashboards without the time-heavy process of HTML and CSS editing.
Take a look at this. I mean, look, we got a ship over here. We've got, right here giving the percentages or some kind of data that you're looking, and see the background here is green. It can turn color saying red. We need to look at this. And you can get graphs in here. You can build your own customized graphs. Let's see if he adds some more here. Wow, look at this. This is pretty cool. I haven't seen something like this. Look at this. You show the ship and you're showing areas on the ship. This is just data, folks, that you're pulling in, but it's building this for you. So the state of Texas has this. Some companies that I have it. I can't say I'm an expert at Splunk, but it is a pretty impressive that you're able to, pull in all of this information and build these dashboards. Okay, it's pretty cool. Splunk is a pretty cool tool. Okay, so that is Splunk. I'm going to show you one more tool and then we'll be done. This is Dynatrace. Dynatrace. So I've spent several years working with a tool called Intrascope that does something similar to Dynatrace. But then I went to work for a company that wanted to replace Intrascope with Dynatrace. And I'm telling you, Dynatrace was, pretty awesome. Let's see if they've got a, and see, once again, they started with application performance.
And then they started branching out, going, you know, okay, well, yeah, we can do infrastructure too. We can do this, 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 and this. So let's go to application and microservices. Let's see if they've got a tour the platform. Oh, it's going to let us go and actually tour from that perspective. And so I was actually, but I really want a video. I was actually basically working with, oh, here we go, working with this company, and we were replacing it. And so I got to work with this tool. This tool is awesome. And honestly, if somebody called me up right now and said, hey, we'd like you to get Dynatrace working for us, I would probably say, okay, yep, you know, because it was so fun to work with. It builds, look at this, it builds these little connectivities. This is between applications. So you have, you know, app to app to app to app. And over here, see, it categorizes them: applications, services, processes, hosts, data centers. So you can have, you know, to build this little graphical map over here. And then you get where you can do drill downs. Look at this, folks. Notice, here's the application. The application is called Easy Travel. This is a web-based application. Somebody wrote it with Java as an example. So for you developers out there, you would use a tool like this to troubleshoot your code. Okay? And here we go. Here are the different, so you've got this application called Easy Travel, and these would be different functionalities that you programmed into it. So this would be, you know, a potential Java class that you designed right here. Or, you know, in the world of a Unix script, you know how you have a function, you have a separate little program within the program that you can call. That's what this is. And it's giving you performance information. And then that shows that, hey, it made, you know, calls to this. Now, this might be another, like a microservice. This could be inside a container running. Each one of these could be a container. Here's the main program in container one that calls the other, that calls the other. And this is going to show you what the response times are. Over here, when you click on it, look over here, you get detailed information. It's showing you the time in a little graph here that it's spent doing each section of the code, each one of these. And then here, look at this, folks. This to me was awesome. Let me see if I can blow it up. Yeah. This is going into the code. It goes into the code. That's what really, you know, and hold on, let me zoom in. Let me get a little bigger here. You know, look at this. Socket, native application, credit card verification, right here. This is Java, okay? ASP.NET. It's making a back-end call to a .NET process running on a Windows process. In this case, it is a back-end connection. This means that this Java application is running on a Unix server going over connecting to a Unix server. See, it does get connection. It's using Apache contact. This is a JDBC call, meaning a database call. And it's running a prepare statement. It's giving the times here. I was trying to get a good zoom. I don't know if this is too tiny for you. It's giving times right here, the duration. Okay, and look, over here to the left, it's actually, oh, there we go. That looks better. Here, this is called the story. This is a booking service. They designed this little travel program to show folks what their software looked like. But look at this. Validate credit card. All of these are portions of the code that a developer developed. Okay? All of this. And here, you see these right here? These are SQL queries. These are actually SQL queries. Select from credit card as where blah, blah, blah. Okay? Get enabled. Folks, this software, I can't tell you how, this is the most awesome software. It really is. I've been doing web-based application, but I've only seen one other, App Dynamics. I've worked with App Dynamics. It'll drill down like this.
but these guys have got it like they're leading, and they're showing you here. We are the leading in the industry now. Look at this, Dynatrace, leader. They have just bumped up above everyone. And then here, this one's not too bad. This one's by different technologies. It is showing you .NET, Apache Tomcat, OpenStack, Java, ASP.NET, MySQL. It's basically breaking it down into the technology, and you can get a technology overview that you are doing. I haven't seen any of the monitoring tools have that dashboard. And then here, pushing new code to production is faster with higher quality. But here, once again, they're showing you how it traverses the code. See, easy travel web, connects to customer front end, connects to a booking service, connects to a credit card verification. It is showing you the flow of the application. Okay. This is what I have done for like the past 10 years, is working with this kind of software. And here, look at this, automatic SQL and NoSQL database monitoring. Look at this, it's showing you the actual SQL query. Now, before, it was showing us a summary of the SQL query to just give us an idea. Oh, it's doing that, it's doing that. Now is where you're really just delving into these database statements. Okay, these database statements. Okay, well, folks, that is it for monitoring. Any questions? Any questions on monitoring? Okay, I hope you enjoyed that. One of my favorite chapters, because that's kind of what I do, is that last tool that I showed you. And I could show you a couple more, but it is getting late. Let me see, 29, chapter 29. Let me see how many slides this is. Yeah, I tell you what, there's not that many slides, but I want to go over the lab, folks, and it's 11:37. So I'm gonna go straight over and start showing the lab, and we'll go over chapter 29 after Thanksgiving. Okay, and really that performance. There's not too much to it, but I definitely want to go over the two labs. So let me get out of this. And we are looking at 12 and 13. Okay. So give me 2 seconds. I'm going to pull up the lab. Okay, so the next lab is Red Hat Linux, folks. And for this lab, you are going to have to register at Red Hat as a developer. Okay, and so I tell you here, and hold on, what do I got? Let me. Oh, did it time out? Yeah, it did. It's not very nice. What is my dream job as a child? Sorry, you don't get to know. Let's go to UNIX. And let's go to lab assignments. Okay. So here we go. So lab 12 is Red Hat. Now, folks, I've given you instructions on CentOS. There's not much difference in Red Hat, but you'll notice it says for this lab, you're going to require Red Hat operating system based off online instructions. Part of being a Unix administrator is to utilize documentation to install an operating system and packages or software. Complete the following below. Once Red Hat is installed, provide a screenshot. Same 2 screenshots. I want you to load the GUI. Just show me that, hey, here's my login with the name, and here is, I'm bringing up the browser, and here we go, Professor Wade, here is the browser. But you have to register your register with the developer, okay? Provide a username, use your ACC and email address. For the company address, you can just go ahead and put Austin Community College. I talked with Red Hat. We are a Red Hat partner, and I did talk with them, and they said, yeah, just have the student register their ACC email and use ACC as the company and the address. So let's go to the developer. Let's make sure that the URLs. So here you go. Build here, go anywhere. Have a Red Hat account where you're going to, learn about the benefits of Red Hat Development Program membership. Now, it used to be down right here at the bottom that you had join Red Hat Developer. Yep, still there. So here we go. We're going to create a Red Hat account. Choose a Red Hat login, an email address, your job role. You could say student, choose a password, and create your developer account. Now, what is that developer account going to do? It's going to give you a free license in order to be able to license the software. And let me pull mine up and just see if I can get in. It's been a semester. Oh, cool. I got it still cached. Awesome. So I'm in now. And notice that there's a lot of stuff you can do as a Red Hat developer. Now, why should you also learn about Red Hat? Well, because that's what most companies are using. It gives you a leg up. Oh, yeah, I've loaded Red Hat. I'm familiar with Red Hat. And so I'm logged in right now. I just wanted to see if I could log in. But, let's see, developer sandbox. Start your OpenShift experience. You can play around with OpenShift if you want. Products, you can look at their different products from Red Hat developers programs. But let's go back. Once you have registered, and the main reason you're registering, folks, they'll let you download install the software, but they won't let you do updates. So you'll be able to, download, let's check and see if my link is adequate. I want to make sure that they haven't changed it. Featured downloads, look right here. Red Hat Enterprise Linux. Download now. No cost for developer subscription. Activate your subscription. Okay, so here we go. I can download this DVD ISO right here. Okay, usually I don't do the boot ISO. Boot ISO just means boot the Red Hat system, and then it's going to pull it all down. So I usually do this DVD ISO right here, this x86 64. And then what you're going to do is just like you did with CentOS. Well, there's the ISO. You're going to boot off of it. Okay. Activate your subscription, and you won't be able to activate it unless you actually register. Okay, register. So, and let's go over here, go back. So you've got the download link works. You've got where to go register. Once again, it was at the bottom of the page. Let's go click on that again. Bottom of the page right here. It's pretty much in multiple places. Join the developer program right there. There you go. Create your account. And let's see if I'm still logged in over here. So I use my ACC email. You're going to use yours. Log in. And let's go over here. Yep, there I am. So look at this. You can get training, certification, subscriptions. And this is the area where it's going to redirect you. But this is where you get your subscription. Notice I just clicked on my little deal here. Let's see if it takes me over. Let's see if I still have my subscription out there. See where it says active subscriptions? And I can click on, these active subscriptions here. And Red Hat developer subscription for individual. Let's see, start date 3/5, end date May. So I have an active subscription right here. Then I also have Red Hat beta access, and that is still valid. You can't get these unless you register, and you're going to need them to get the updates. Okay. And then finally, installing Linux on VMware. You click on it. Here, let's see if the instruction link is valid. Okay. Download Red Hat link at no cost. And give me 2 seconds. Let's just see. It looks like maybe the link's changed. Build, accelerate your enterprise class Java. I want to check all the links. Install Red Hat Linux 8 using a graphical user interface. Installing Red Hat Linux 8 using the graphical user interface. Okay. And right here. And this is not as good as it used to be. But in reality, folks, you should be able to just install it. Here's a ISO register system cloud. So here's all of the instructions. Downloading an installation image. You've already done that. Downloading an ISO, creating a bootable installation boot media, preparing for installation. Right here. Installing Red Hat Enterprise Linux on AMD Intel 64. Installing Red Hat using an ISO image from the customer portal. From a boot menu, select Linux. Let's see if they had VMware. Creating a bootable DVD. Preparing for installation source, type of install source. Oh, and customize your configuring language and location. Regions. It's going to be the same process as CentOS, folks. So it looks like it has changed just a little bit. I don't really see the nice image that was there before. So once again, the link did take us to installing Linux on VMware, and it looks like it's changed. Right here, deploy, perform a standard Red Hat. Let's see if they have VMware up here again. Yeah, unfortunately, this is it right here. It looks like they don't have it looks like they've modified their documentation. So what I'm going to go do is I'm going to edit this. Okay. And James says he Googled it. But honestly, the main process, James, is exactly what you've been doing with Fedora Core and all the others. You have to build the virtual machine. You then have to click. Okay. But here's the thing. One of the things that you want to watch for is when you Google something, I always look for, and this is just best practices. Let's Google. Let's go. And this was version 8. Install Red Hat version 8 on VMware. One of the things that you want to do, folks, is beware that, notice, see how it says how to install Red Hat on Linux 8.1, but where's it coming from? It's not coming from necessarily a adequate source. So whenever you Google something in the technology world, the best approach is to look for something that comes from the vendor first. Don't necessarily trust something that's coming from a techie, because yes, it could be right. I mean, I have found a bunch of stuff from other techies, but I value more Red Hat or the vendor above that. So that's just an FYI. Okay. Linux config, how to install VMware. Now, if you want to browse these, yeah. But what I would look for first, and what I always, and there's videos here as well out here. What I look for is this. Here, I mean, here's Billy Soft Academy. Here's blogs.vmware. Now, I would trust VMware over Billy's Soft Academy. Let's see. Oh, look here. Developers, redhat.com. Here's VirtualBox. Here's, problems in VM. Well, we're not using VMware Workstation. Here's look, here's the exact link I just clicked on. Okay. Let's click on this one and just take a look. VirtualBox install. Now, we're not using VirtualBox, but it would be very similar, okay, because it's going to come up. So, and look, does this not look exactly the same? Does it look not exactly the same? No. I know, James, there's nothing wrong with what you did. I just want to make sure that, because I don't think I've ever said in the class it just clicked in me now. I don't think I've said it in any of my classes. I've said, oh, go Google it. Go Google it. Yeah, you guys have Google. But I've always used a process in my head for years that I prioritize my Google by, okay, is there a link from the vendor? Is there any kind of links from the vendor? I'm going to use those over everybody. And then I move down to the next level, like a vendor that I know that is giving me information about another vendor, because I know that, like we saw something that came from VMware. That's good. There's talking about Red Hat. Then I move to the third level and I look for, after a while, you recognize people who have their sites or their blogs, and you're like, oh yeah, I know that. This person here, like there's a database, an Oracle database guy out there that I'm familiar with. He runs a consulting company. I go to his site a lot of times. If I see a link on his site, I trust him. So, I would trust this right here, which really, if you look at it, this is the install. And here we go. Once again, you can install it as a workstation. You can install it, with server with GUI. That's what I'm really looking for, this lab server with GUI. Okay. And here, I'll put this in the chat session right here. And I think I'm going to go over here just in case and edit this and just say down here, another source Okay, so I'm going to put this link up here because I like that link. There we go. Because the other link that used to be there, and it worked last last semester, and I'm going to put up here, install server with GUI. It actually worked, and it took you right to the VMware installation. It actually had a deal, install this on VMware, install this. And so they've obviously, changed the link. Okay. So really that's it. It's all you're going to do here with Red Hat. Now, the thing is that when we get to this next section here, it's going to ask you to get the subscription installed. Let's go take a look at that install process here. This looks really good. Okay. This is exactly what the link was, but the guy probably took this and then it boots up. And so here we go. There we go right there. Install updates, enabling the cockpit, VirtualBox guest editions. No, we don't care about that. App stream, it doesn't show it. Okay. So just get that installed. If you can get that installed by our next class, the next two labs are pretty quick. As a matter of fact, I'm not going to have you reinstall the software unless you want. We're going to look at the next lab here in just a minute. So hold on. Just out of curiosity, Red Hat, Release 8, VMware, quick install. Let's just see if they've got it out there and they've changed the link somewhere. Aha. Oh, come on. Seriously? VirtualBox, Hyper-V, Bare Metal, Python. Oh, man, that's a bummer. That annoys me. Okay. Let's go load more and just see. 2 seconds here, folks. I guess they removed the VMware link. Yep. We'll try one more thing. I'll get rid of quick. And maybe I'll write to say, hey, why did you get rid of the VMware one? But they did. That's annoying. Really, the only difference is that the virtual machine creation is a little different, but you should know how to do that because it's the same for all of the other software. Remember, just give it a little more memory, maybe CPU, and that's it. Okay. And you can use this, same install process for VMware. Okay. And then let's see. Let me go back over here. Okay. So let's go over the next lab. And folks, I tell you what, just get Red Hat going and get your registration and do Red Hat. Don't worry about Red Hat and Java. These two labs are pretty quick. I'm gonna look at this and show you, but on the schedule I said lab 12 and 13. It is not difficult to do these labs. These labs here, and just let's make sure they're there. How to install Java 8 and 11 on Red Hat Linux 8.
Okay. And you don't have to install Java 8. You can just do Java 11. And there's even a video. And really, look, all you're doing is yum. And the purpose of these next two labs after this, the Java and the PHP, are for you to do a hello world, but really for you to learn how to use yum to pull down packages and install on this system. Because this is what we do. We will load Red Hat Linux, and then a developer will come and say, well, I need Java. You know, we're developing Java, or I need this package, OpenSSH, because we're going to do some secure shell with it. Or I need OpenSSL for secure socket layers. And really, so here, look, yum, you know, and then you do a list of OpenJDK, you do a yum install OpenJDK, and then you check the Java version. And then in here, you're going to see that they have a hello world right here. You're going to do a hello world program, and you're going to, what I expect is for you to basically print out hello world. Okay. This one's on steroids. And I think the upper above right here, you can pick which version. So Java version, this is 1.8. So really, you're going to get the OpenJDK Java programs here. And then you are going to basically do a hello world program. So here, look, here's JDK 8 right here, or you could do JDK 11. And then all you got to do is really, you know, just type this in and execute it. Okay. That is all you're doing in this program. But you can wait if you want to. And look, here they're actually even giving you a video. But here is the Hello World program right here. Look, cat, Hello World. So all you got to do, not the one at the bottom, but this one right here. That's what I was looking for. Public class, Hello World. There it is right there. And then you type it in and you do a hello world. This is the one for Java 11. And up here, it's for Java 8. So all you have to do is really go yum install Java 8 and type in this right here. But get it to work. And as always, you do a cat, and then you type it in, and it should, see right there, you type in Java C, hello world, and it should say hello world. So literally, this lab is right there. That's all you do. You're installing Java, the Open Java Developer Kit. You are writing a hello world Java program. Pretty easy. This is what I just highlighted is really all you have to do. Or here, you go, okay, I'm going to install Java 11. And you write the Java hello world here. So right here, you have a choice. This one or this one. That's all you do. You don't even have to go down here, you know, where find the Java packages, switch Java versions, select Java versions with alternatives. You don't have to do all of this stuff down below. Unless you're a developer and you are doing Java and you want to play around, you don't have to go below this video. All you have to do is here. Pick one. Do you want to do Java 11? And if you do, right here. And if you want to do Java 8, you do this one. Any questions on this lab? And so this lab builds upon that lab that you did. So as an example, you load Red Hat and you do the server with GUI. You bring it up. You show me the login with your name on it. You show me Firefox. That's all I need. This lab's done. Then you click on this link. You go and either select, okay, I'm going to do 8 right up here, or I'm going to do 11. Once again, you're going to use VI to VI this program. You're going to call it helloworld.java. And then you're going to type in Java C, hello world, and it should print out hello world. And you're going to show me that. Okay.
Now, if you get ambitious, and once again, this I'd like done when we come back for class. Time we come back for class, you need to have you be all caught up with UNIX Lab 12 after Thanksgiving. Okay, remember, you got 2 weeks before the next class. So catch up with all the quizzes, the ones we went with today, and catch up with all the labs. Remember, we got to the monitoring. We did get to the performance chapter, but we got to the monitoring chapter. So you can stop there. And then here, you can do the red hat. And let's go, and here, all you're doing is the same thing. I give you the PHP program, but I give you the command right here. We're going to do df info PHP, DNF module PHP 7.2 development. I don't care what the latest version is. I just want you to get PHP working. Okay. You don't have to do this though, or this one, but you're going to be doing it on the same version. I'm not making you use the Red Hat instance created in Lab 12. Use the instance created in Lab 12. So you're just going to download Red Hat once, and you're going to then add different packages to it. That's the whole purpose of these 13 and 14, is to add development packages. This is the kind of stuff you have to do out in the field. You'll download Red Hat Linux, and then they'll tell you what they need for their development environment. Okay. In this case, I had you do Java and PHP, and then you're going to write the Java and the PHP Hello World program. And then we'll discuss this. We're going to look at Red Hat security. Okay. Any questions on the labs, folks? Answer no in the chat session or answer yes. And so really you can do just UNIX Lab 12, get that done. And then these 2 labs you can save. Because the one thing I need to show you is how to, because I didn't see it in that install process. Maybe I missed it. But the original install process had the subscription service, where what's going to happen is this will work. But when you go to try and get packages, it's going to tell you it can't get the packages, that you've got to register this server. And in the GUI, the Red Hat Linux GUI, there is where you can click on it. And you could do this if you want to try and play around. But see, I registered a machine with this. But when you install, and did I get rid of it? I think I got rid of it. When you install there it is, the operating system, you're going to, as a matter of fact, I believe, and for some reason this didn't work too well, maybe it'll improve, but right here, you see this? It is here, system registration during first boot. It comes up and asks what's your Red Hat account information. And see where it says, manually attach subscription after? You don't want to do this. But you see this login and password when you first log in? It's the login and password, folks, of your Red Hat account. If you don't have the Red Hat account, it won't register the subscription. You have to have your Red Hat account and logged in, or it won't register the subscription. You have to have your development account, or it won't register. And you use your development account login and password. You forget it, well, it's not going to do it. Now, there is, as you can see, manually attached. There's a way to do it manually. Okay, here we go. System registration from the command line. What this does is you log in and you type subscription manager, register, auto attach, and it'll go out and it'll register. You have to register the system. If you don't register the system, well, then it will not pull the updates for labs 13 and 14. There is also, and let me close some of these. I got too many of them open now. That's what I want to show you. Hold on. There's where the software is. When you pull it up and you click over here, you'll actually see in the GUI as well, it'll have a subscription manager that you can go in there and you can register it with the GUI as well. Okay, so there's actually 3 ways to register your subscription. One way is at boot time, it is going to boot up. Hold on, it's going to give you this login. Just make sure you don't click on manually attach, because what that's saying is don't attach the subscription to this. I'll do it later manually. If you go past here and it didn't register, meaning you did lab 13 or 14, and it's saying, hey, you got to register, well, then you have to then go do it manually from the command line right here, or from the GUI right here. There, you click on this and you look for subscription, and it's in there. Okay, and it's in there. Okay. Okay. But let's take a look here, because if we go to the subscription, let's see if I'll show you something else here really quick. Okay. So here's a subscription. Look at all of this. This is all the stuff that subscription is good for. All this different software. But see where it says systems up here? You should be able to click on systems up here and actually see your registered system. Let's see if it's still got mine or if it's toasted it because it's been in there too long. Yeah, look, see, here are my systems. This was for, you know, a class last semester. Okay. But this is the actual, you know, server name. I didn't change the name. I just did a default install. But when you register your system, you should be able to go over here and look for it. Should show you. How did I get here? Well, I clicked on my little icon over here, and I clicked on subscriptions. And then it takes you to this little GUI here where, see, here's the virtual machine. This was November 30. So this was my fall class. And I didn't teach it during the summer, so that other system is going to be for the spring class. And I probably need to load this up just in case somebody asks me, okay, where's the little GUI, because it's not working, and I can take them through it and show. Okay. So once again, you know, that is it for this lab. You know, I've shown you, you know, and the links are up on Blackboard now. Okay. Any questions on this, on lab 12, 13, or 14? So no in the chat, or feel free. Yeah, looks like Mohammed, you got your question answered, but it's also in the lab. I tell you how to start MySQL in the lab. Everything's in the lab for lab 11. All the instructions on how to stop it, start it, and use the system CTL is in the lab. So just go back and take a look at those lab instructions. Okay. Now, what I will tell you too is with that lab, if you didn't install the proper software with lab 11, and I do get folks that sometimes do this, they don't click on all of the software over on the right side, and then they go, well, MySQL isn't there. And I'll say, and they'll ask me, well, can I just install the package? And I'll say no, because here's the thing. If you make a mistake and you don't install something, what do? We go back and we fix our mistakes. Okay. We go back and redo it because we didn't do it correctly. And my recommendation for students, you know, if, you know, you, for example, Red Hat here, if you, you know, if you install Red Hat and you don't get the GUI up because you didn't click on server with GUI over here, or you clicked on, you know, you could click on workstation, but I want you to do the server because that's what we're doing. We don't use a GUI. Why am I having you do a GUI? Just because it's the first version and the GUI is nice. And from a developer's perspective, if they're developing, having a desktop with a GUI is nice for them because they can, you know, use that GUI. But if you didn't click on the GUI and you just clicked on server, it's not going to have a GUI. Or if you click on minimal install, you know, you want to click on these right over here, these development tools. But the point is that if the GUI doesn't come up, and I've had students that installed, the GUI doesn't come up, and they don't get full credit. And I've said, you need to go back and, well, can't I just install the GUI packages? No. Okay. Could we? Yes. Yes, we could do that. Why don't I want you to do it? Because part of being an IT professional is following instructions that your boss gives you, or following instructions that come from, the internet, and making sure you go over everything quickly. Even folks, I've been doing this for years, and sometimes because it's worse when you've been doing it a while, because you're like, oh yeah, I know that. Yep, know that. I know that. Yep. And then you forget one little process. Okay. Well, folks, that is it for our labs. At this point, you can, oops, hold on. I didn't take roll call. Give me 2 seconds, folks. Alicia, the instructions are on Blackboard. You download the ISO, the DVD ISO. And by the way, any ISO can generate a DVD, but you download the ISO, from Blackboard. I kind of discussed that at the very beginning. It is on Blackboard right here. Download, you click on the download link, and you're looking for that Red Hat release, ISO. So you get here, see featured downloads, Red Hat Enterprise right here. And then you get to download right here. Look at this, download Red Hat at no cost. Unfortunately, there's like 3 links here. And the one we are looking for is right here, 8.5. Tell you what I'm going to do, folks. I'm going to put this in the chat session. You can link on it right now. See, everyone? Yes. Right here, this 8664 DVD ISO. Folks, the boot ISO, it just allows you to boot. And then it will ask you if you want to install, but all it means is your system's going to be sitting there downloading stuff off the internet. I don't like doing that. I'd rather just download the entire 4 gig or 9 gig ISO. That's my preference. If you want to do it from boot, instructions are slightly different sometimes with the boot, because it's going to go out there and download. So I'd rather just get me the DVD ISO in one. That's what I do. That's my preference. Yeah, there's only this top option right here. That's it. This X64 for your machine should work. 10 gigs. It's only 10 gigs. Okay. It's only 10 gigs. No. So just download the 8.5. See, I don't like beta. I don't do beta. If we are downloading something, we're going to download the latest tested version that's been tested, 8.5. We don't want beta. Now, if you want to play around with beta later on, yeah, sometimes we download the beta version. People are helping Red Hat, or they want to test it out. This is older, 8.4, 7.9, 8.2. All of them are old. So whenever I install software, I install the latest and greatest, and I don't want beta versions. Beta means not tested. Okay, beta means not tested. So this is the one we want to download right here, top one. This version, 8.5. That's the latest tested version. Okay. Any other questions, folks? Give me 2 seconds. Okay, I did get the roll call. Let me save as. Any questions? And I will. That was a very good question, Elisa. Give me 2 seconds. 11:20. Let me save the roll call. And what I'm going to do. Okay, I know some of you had a couple of questions up top, but give me a chance. By the way, when you're asking about other labs, wait until I get to the section that says, okay, if you have other questions on other labs. Right now, we're just making sure that, everybody understands. And let me see, I should be able to copy this in here, I think. Let's go right up here, edit, or I think you've got to save it, don't I? Yeah, I wish they would let us save as. Let's go to ACC. And okay, well, folks, I'm just going to try and get this in there. I don't know if I'll be able to get it in here with this one. There should be one over here that allows me to add this to it. But let's see, install server with GUI. Yeah. Yeah, I don't see it on this one. Okay. Okay, I'll pop that in there just in case. Any other questions on today's lab, folks, on loading Red Hat Linux? Okay, well, that is it for class today. Have a wonderful Thanksgiving. I will see all of y'all in 2 weeks on Saturday. So have a great Thanksgiving. For those of you that have any questions on the other labs, feel free to stay and ask a question. But have a great vacation. Okay. And try to get this lab done by next class in 2 weeks. And if you can do the Red Hat, Java and PHP, awesome. Try to get those done as well. Listen, I will definitely try to get it up today. The problem is that once we end the meeting, it processes and it takes 2 hours, especially maybe even 3, because we've been recording for 3 hours. So it probably won't be up until this afternoon. Okay, I'll get it up this afternoon for you sometime, but it'll probably be like 4 or 5 o'clock before it finishes processing. So, okay. Let's see. Had a couple of questions up here. Lab 6. Oh, you're talking about, so that lab was meant for, that lab was really meant that each person had to do the lab without me giving any answers on that, just because it was an accumulation of the other labs. So exercise 2. So I gave you what the actual output was down here. And I also gave you the tar command. So when we troubleshoot this, what you could have done was come up with the tar command and tested the tar command. When we write a script, what we want to do is basically, we want to make sure that, okay, does this work? Is this command work that Professor Wade gave me? You can also go back and watch the video on this, but what questions or what difficulty are you having with this particular portion? With this particular command? Nicholas, you asked, oh, Nicholas Brammel's gone. I didn't get his question. Asked if they use Red Hat workstations. No, they don't. They use Microsoft, and they'll use a development tool. So maybe you'll watch the recording, but they'll use a Microsoft tool and not a Microsoft tool, but they'll use a Microsoft desktop, and then they'll have some tool that has all the Java libraries, like Eclipse is a Java development tool that'll integrate with the Linux machines. So they usually don't have a development machine. Although saying that, there have been a couple places that I have seen where they'll do that. That's a long time ago. Okay, so if it doesn't work, then you probably need to go back and watch the video on it, but I'll show it to you again. Are you saying this doesn't work? The tar command doesn't work right here? Are you saying the tar command itself doesn't work? Is that the problem you're having? Okay, so I'm going to unmute your microphone so you can talk, and then you can ask me the question. Because you said it didn't work, and then you said it worked. So you should be able to unmute your own microphone now and ask me the questions.
So, Professor,
Yeah.
yeah, when I changed the variables with the file, you need to you ask it to inverse the files with the dollar sign 1, 2, 3, right?
No. Yeah, inside the file, yes, but the $1, 2, and 3 are coming from these entries right here. So this entry right here, that would be $1. This entry right here, $2. These entries right here, $3. So really all you had to do is up here, you were manually inputting. So if you got these there, all you have to do is uncomment them. So you added these as like a read minus P, read minus P, read minus P, and you gave them some variable. So now what may have gotten you stuck is you don't do a $1 equal, and I probably should have rotated it not to confuse anybody, but in shell scripting, you do it like this. Okay, so watch my screen, you would do backup files equal $1. You know, backup name equals $2. And backup location equals $3. And then you have to execute the command with, of course, the command name. And then you have to put these in quotes to be $1, and quotes to be $2, and quotes, these double quotes, to be $3. So it's going to take this $1, put it into this. So it takes the $1 and it's going to put it into this as the variable. It's going to take $2, put it into this as the variable. Take $3 and put it into this as the variable. And then you're going to take the tar command up here, and you should already have those variables up there from exercise 1. So really, to go from exercise 1 to 2, you're just uncommenting, putting a pound sign in front of these, you know, in front of these read commands right here, the read minus P with the prompt. You're just going to put pound signs in front of them in the script, and then add these right below it and just use the same variable names, and you're done.
Yeah, maybe that's the pound key. I didn't add the pound key for those.
Okay?
Yeah, I will try it again. All right, thank you.
Uh-huh. Okay, anybody else have any questions? Looks like I got Easton, Isaiah, and Nicholas. Do you have any question? I got a question on, or is that it? Oh, looks like, okay. Nope, that's it. Okay, so Easton, Isaiah, or Nicholas, are you there? Do you have any questions? Answer no or ask a question. Okay, well, folks, I am going to, because I got 3 folks dialed in, but I'm not seeing anything in the chat session. So I'm going to stop the recording.